My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
So, I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GlowCloud team.
Today we're going to talk about multi-cloud architectures. You know, there was another outage today at AWS or yesterday, and it makes us think each time, should we be in a single cloud? Now, for those of you that know me, you know that I've been teaching multi-cloud architecture for years, and most of the clients I work with are large organizations, healthcare organizations, global banks and things. They can't put themselves in a single cloud for a lot of reasons. And as it turns out, 98% of enterprises choose not to be in a single cloud for a lot of reasons. So what we're going to talk about today is, and just to let everybody know, is how clouds are actually built and how and where clouds fail. So you can see when and where you can survive an outage. For example, this outage at AWS, you could have worked around it all in AWS by being in other regions, but in other failures, that would not be the case. So we're really going to talk about what goes into a cloud, how a cloud's actually designed, and how things fail. We're also going to talk about why a cloud is more likely to fail than your average data center that's well run by a single organization. And there's good reasons for that. Then we're going to talk about the types of cloud failures. What happens if it's isolated? When can't you isolate it? When is it going to be global? When is it going to affect the entire environment? And when won't it? So then you can think about how you architect around it. Then we're going to talk about the trade-offs between your various cloud architectures, your hybrid cloud, your single cloud, your multi-cloud, and your hybrid multi-cloud. Because to be fair, nothing's free. And no matter what we do, we gain something, we lose something. So the key, we want to talk about what those are. And then I'm going to talk about how you to determine which things need to be multi-cloud and which things don't. And when you need multi-cloud and when you don't. And then we'll have fun and we'll start designing multi-cloud architecture. So that's going to be the theme for today. So let me know you're here. Say something in the chat box. Let us know. Tell me, hashtag multi-cloud architecture so that I know you're here. And I also wanted to tell you about some free things and some exciting things we have going on. On Thursday this week, starting for the next 5 weeks, we're going to have a free cybersecurity fundamentals bootcamp on Zoom. I love doing these kind of things. And by doing it on Zoom, you'll be able to ask questions and get your questions asked live. So please join us in the free cybersecurity bootcamp, which is going to be on starting this Thursday for the next 5 weeks, live and free on Zoom, courtesy of Go Cloud Careers. I also want to talk about the security webinar we have going on Friday, where we're going to talk about how to become a security architect. Where we're going to talk about what is a security architect, what does a security architect actually do, the skills that are actually there that you need to become a security architect, how to stand out as a security architect. So we've got a lot of fun stuff today. So it is good to see everyone. If you're having a good time, maybe think about liking the videos, subscribing to our channel, hitting that notification bell if you're having a good time. And also, please make sure to check out the description of this video. There are usually some free things hiding in there as well. So Tyrone, I love it. Multi-cloud architecture. Jose, well, good to see you. Multi-cloud architecture. Adrian, multi-cloud architecture. I love this. Omigo, hi everyone. It's terrific. And Jason, multi-cloud architecture. So wonderful, wonderful, wonderful. So I love seeing this, Mark. I like seeing Island Boy 1779. Which island are you from? I love islands myself personally. My favorites are Jamaica and typically Santorini of all the islands. But I've spent a lot of time on a lot of islands and love so many of them. Okay, so let's actually talk about multi-cloud architecture. So I want to talk about how clouds are actually built. And what I think that I'll do is I'll talk and walk. We're going to design a cloud in real time on PowerPoint, so you know what goes in the cloud. Then we're going to show how the cloud data centers are connected to other regions. So, and then we're going to talk about and show you where the failure points are on a single cloud so you can understand it, or any data center. And then I want you to, we're going to go through the scale and the bigger challenges that are with scale. So let's first map out and that's not what we're going to trying to be doing right now. We're going to get to that at a point, but we're going to map out some various things and how a cloud would be designed. And if anybody has any questions, just pop them in the chat box. Now, as I start designing some of this cloud so you can see it, because I've been designing clouds the way the cloud providers are designed for decades now. So I want you to ask questions in the chat box if you have it. And I'm periodically going to be asking you all questions. So please, if I ask a question, respond in the chat box. And that way I know you heard me. If not, I might go back and do something once or twice because I really want to know that you got it. You heard me, what we're talking about. So let's have some fun and let's talk about how a cloud is designed. So I'm going to first design a cloud provider's data center or availability zone. And I want you to understand what goes into it. So the first thing we have to have coming into any kind of data center is going to be the following. Here's going to be a data center. It is going to be a very large building, very large building. Now, what a data center is going to need, especially an AI data center, but any data center, is an incredible amount of power. You know, I remember when we used to build data centers that were megawatts of power, and now we're talking gigawatts and more. So we really need a lot of power coming in. So typically speaking, we will have power companies coming in, ideally more than one. And so we're just going to call this power. Now understand that power comes in at 1 voltage and our systems uses another. So that means
you might want to adjust your PowerPoint scene just a bit.
Okay, thank you.
Yep.
Okay, so we're going to have a lot of power coming in, and we have to make sure we've got redundancy in power transformers. Now, generally, the power that comes in is dirty. So typically in a large environment like this, they typically have a power conditioner or a UPS system. And this is basically large batteries, smooths out the power. The batteries can power the systems for maybe 5 minutes, 10 minutes, 15 minutes until the generators kick in. So there's typically some kind of power systems. I'm going to call it a UPS because many organizations have that uninterruptible power supply that they use for short term. Now, we're typically also in a building like this because the data center can't afford to go down and power is critical. We're typically going to have multiple generators. Now, if we have generators, when we design these systems, we have to worry about fuel. If we're lucky and we have natural gas coming into those generators, it's great. If it's not, we don't have access to natural gas and we need to put diesel fuel in the ground, for example, diesel fuel in a tank, how big do those tanks need to be? And we have to understand in a disaster that we have to be able to get fuel in and out. So we need to be thinking heavily on these. Now, going out to the outside world, we're going to have 2 sets of networking connections coming in. We're going to have these networking connections that are going to be going to other things. So let's say we're in a cloud provider region. We're going to have these intranet. And intranet is going to be the network that connects their systems together. So what you will see ultimately is at the edge, you're going to have these intranet connections that are going to go to the other cloud providers' environments. Now, what you're also going to see, at least in one or two of these buildings, but potentially all of them, depending upon how the cloud provider is architected, is you're going to need your internet connections. And the internet connections are going to various internet service providers, which is off of their network, like Verizon, for example, or AT&T or NTT or Etisalat, for example, in Dubai, or Vodafone or Orange, depending upon what you actually have in the world, or Telefonica in Spain. NTT in Japan. So there's lots of big, large internet service providers, and I've done a lot of consulting with many of them in my earlier days as a network architect. So, and architecting data centers. So that's typically what we have coming in. Now, what I need you to also understand is we are going to have hundreds, well, actually probably have thousands in the cloud providers' data centers of routers and switches. And that's going to be the networking, and that's going to be a lot of work. And now I'm just going to put like routers and switches in here, but I want to make it very clear that routing and switches are fairly complicated. In fact, this networking thing is so complicated. I think that's the primary driver people went to cloud computing, was not to have to figure this out and deal with as much of the networking complexity. But we've got a lot of routing and switching going on. And that also means we've got routing protocols to determine how our traffic can go from point A to point B. We're typically pushing a whole lot of VLANs in a data center like this. So we often get into this world where we're pushing VLANs over BGP. Now, the key to remember is this stuff is really complicated, and there's not that many people that truly understand it. If anything happens on the routing, if anything major happens on the way the routes are there, for example, a bad route is injected into the system, it can take down all of those. And I can tell you, I have seen so many outages on the network side because, they had somebody that didn't truly understand networking. They had a person that, was a little bit of I call them the hobbyist type. They knew a little Linux, they knew a little this, they knew a little this, a little this. They touched the network, and the next thing you realize, an entire cloud's down for hours. The networking thing is fairly complicated. It's very specialty. And that's why people like me that worked in networking, when I worked in networking, didn't really know anything other than networking. And, but that's what got me to principal architect status so quickly in my career. Is nobody knew it, and I decided to focus on it. So there's that. So all this stuff is how all the connectivity is going to occur. Now, this is a point of failure. If anything happens with your network and it goes bad, you're down. No network, no nothing. So there's a lot we do on these networks to make them secure. Now, the cloud providers can't take any of the security things that we would naturally do in our data center and do them, because they have to treat thousands of customers where we're only dealing with ourselves. So we lose a lot of security in the networking side in any cloud provider. But this is any data center or cloud provider. Now, the compute that we use in any data center or any cloud provider are the servers. I don't care if they talk about serverless, it's still running on a server. I don't care if they call containers, it's still running on a server. It's all marketing nonsense and fluffy terms that you actually hear. So it all runs on a server. So what's going to happen is this organization is going to have thousands of these power-hungry servers sitting in racks. And these things use a lot of power. Now, if they're full of GPUs, they use a lot more power because, for example, an AMD CPU has a thermal is rated at 350 watts, and you typically have two of them in a big server. So that's 700 watts plus drives and other things. You're typically dealing with maybe 1500 watts for a server. Now, you could be dealing with 3000 watt GPUs now, and a server can have 10 GPUs. So why am I saying this? Well, all this stuff and the network stuff uses plenty of electric, generates heat. For every watt, there is an issue of heat. So the next thing that we need to understand then in these data centers is we need a lot of these air conditioning units. And we need to cool these things, because when these things get hot, what do? They first start slowing themselves down, and then they do unpredictable things. So it's another reason we need so much power in here. Now, these are going to be thousands of servers, and where are the servers going to be plugged into? The network. And then I'm going to show any of the things that connect, and then we're going to connect multiple together like a cloud provider, and then I'm going to show you all the places where this stuff can break. So now we've got our servers, and these servers may have some internal storage, but we can't scale the storage realistically speaking in a server because, what happens if we run out of hard drive space in the server? What should we be done with the servers? That'd be ridiculous. So, other thing that we're going to have in any data center is storage. So what's going to happen is we're going to have basically servers, or these can be just big giant server storage boxes, but they're just servers. And what are they going to look like? We're going to have a tremendous number of hard drives in these things, and they're going to be working in a RAID capacity that's going to give us some data redundancy and also speed and performance and enhanced capacity. So you're going to have all these devices, and I'll show you what these devices are and why we typically use them. Okay, so here we have our hard drives in here. So if the servers are going to need a virtual machine, let's say we've got a virtual machine sitting on the server, what if we could decouple the servers and the storage so this server can now access this or this type of storage? Well, it can. And that's what we do in the data center, and we've done it for decades, and that's block storage. Now, we're also going to have boxes like this that we'll use for backup and archival purposes that'll be object storage, but they're going to be very similar in structure. And we'll have similar servers or these devices doing file storage. So I'm just going to put some storage boxes in here. I'm going to call them storage because it could be block storage, object storage, file storage. I'm just going to call this storage. And that way it can be any of the devices. Now, of course, what do these storage devices do? And how does all this magic connectivity occur? Well, the storage boxes are also connected to the network. And that means anything that has access to the network can potentially access the storage. So here is your typical raw physical data center. Now, if we look at this, there's something else I really want you to see. So where can things go wrong? Hardware-wise, we can lose a drive over here, but the good news, there's redundancy. We can put a new drive in, rebuild the array, and we're good to go. And we've typically backed up the servers. A big power failure, well, that shouldn't be a problem. Now, AWS did have a global outage because that they blamed on a power failure many years ago in the US. Now, no data center that I've ever seen in decades actually has had a power failure because of all of this, at least if it was a well-designed organization. I've seen poorly designed organizations have power failures. They attribute it to a power control system. And what does that mean? It means that, and this could have been a very valid thing, there's some software here, the power control, these industrial systems that controls this. So if this device goes wrong, the power control, all this stuff goes down. Now, that's a pretty bad outage. So if we lose power, we can have something. So if something were to happen to this storage array, it could cause problems. But where your real issue here is your network. If the network goes down, you're down. Now, here's the thing that I haven't described yet. This is all infrastructure, but I'm going to get back to this. We all love our cool cloud functions, right? We like our containers and container orchestration. We love it. We love the ability to just upload your code and run, say, application virtualization. We want to be able to run a function as a service, the equivalent of a Lambda function, Azure function in any data center. So what makes that possible? Ooh, now we get into the fun. And this is the next big place where your cloud provider can fail. Well, what makes all this happen? So we have a layer of software over here that makes the cloud run, and this is called the control plane. Each cloud provider has their own variation of a control plane. Nutanix has their own control plane. OpenStack has its own control plane. AWS has its control plane. And what I want you to think is this. Well, first let's talk about how the control plane works. So you want to create a new virtual machine, same thing as an EC2 instance or a Google Compute Engine instance or an Azure virtual machine or Oracle virtual machine. You want to create that virtual machine. It's got 8 cores and 32 gigs of RAM. You go to that control plane either with an infrastructure as code script, a CLI command, or you go to the cloud provider's management console and you go to create that virtual machine. Now that control plane knows all that exists in here and it keeps track of it. So the control plane says, oh, we're going to put your virtual machine on this server. Now, all of a sudden, you set up a Lambda function, for example, in AWS. The Lambda function hits the control plane. The control plane says, send that to this server. This server has capacity. You want to, and that's the way everything works. So all of it goes through this control plane. Now, your network, the ultimate, like the networks that you have, are going to be in this software-based control plane, which is going to be separate than their actual internal networks for the most part. So here's the next problem. Anybody makes a major software error, this control plane goes down. And the control plane is generally shared between environments. Can you go to the AWS management console or a Google management console or an Azure management console and go over there and set up a virtual machine in Europe? Of course you can. And because of that, let's talk about where this gets next. So before I go on, and let me know, I'm going to check the chat box to see, does everybody understand the control plane and the problem with that control plane if that control plane goes bad? Does everybody see that if everything's connected in the network and the network goes down, you've got nothing? Mi then, Zaba, null, Dipota, whatever language you want to call it, you've got nothing without the network. Let me make sure that you understand that by giving me a hashtag network or a hashtag control plane so I understand that you understand what's going on so far. I'm starting to see some responses. I know everybody gets it. I will move on to the next topic and then talk about how these are all put together. Okay, Jason, I know people are starting to get it. Let me see a few more networks or control planes, and then I get it. And now let's look at the next thing. Okay, good. I'm starting to see it. I know you get it. That makes me happy. So wonderful. Okay, now let's talk about, we take that one thing, and then we're going to further expand upon it. So great. So now let's look at the way these typically, the way a cloud provider's region looks like. So we've got this monster data center over here. We've got another monster data center over here. We've got another monster data center over here. We've got another monster data center over here, for example. And let's say we've got 6 of them inside of a local region. Actually, let's make it a smaller number so we don't run out of space. Now, the key to remember here is that all this stuff is connected to each other in a fairly robust environment, because if you have any kind of outage, you're going to have a problem. So all these things are connected together in a relatively redundant way, typically fully meshed. But that would be something where we'd go something like that, and then something like that. And then we'd actually have to have more connections. But look at it this way. It's going to look something like that. Now, I want you to realize now, once we've got this network, when you're dealing with a large cloud provider, and this is a region like this, you're dealing with a network that is so large that you're actually reaching the breaking points of many things. And I'll show you what I mean next. So the routing protocols that are going to be here, at some point, what ultimately happens, and we saw it with this last AWS outage in a certain way, but I want to describe what happened. So all these routing protocols are working great. Everything's fine. Now, all of a sudden, we've got something happening on this bottom data center, this bottom area that I'm pointing to right now. Its links start flapping, its systems start rebooting, its network goes crazy and goes chaos. Now, each one of these things is sending LSAs from their interior gateway protocol, like intermediate systems to intermediate systems, or OSPF. They've probably got some MPLS things going on, some traffic engineering for more high availability in these systems. Any one problem that causes chaos here can spread to anything that's in the blast radius. So a major network failure in any one of these things could potentially take all this stuff down. So these are each of the cloud provider availability zones in a data center. That's a region. So typically all these things will typically be in one set of routing protocols. And then what do? We then connect multiple regions together through a backbone network, which is a wonderful thing. Wonderful. And typically speaking, we run an interior gateway protocol like OSPF in each one of these because it's local. Although we're really pushing these things at the size they are, then you might almost want to run BGP between each data center, but probably not. Let me just delete that last thing we did. So we're running an interior gateway protocol here like OSPF inside of all of our domains. Let's just add that. And they don't have to be the same interior gateway protocol in each of these domains. And then what do? We have high-speed links between the regions, which we buy from internet service providers, or we run our own submarine cables, depending upon how big we are and how much money we want to spend. And we start connecting these things. And we run BGP between them. And the reason we run BGP between these organizations is BGP theoretically gives us the ability to control the routing information. So if something happens here that's crazy, hopefully it won't spread to here. We're trying to limit the blast radius. We're trying to reduce the number of routes in the routing table. But the reality is sometimes even the best segmentation strategies don't work. And if you have a major network outage in any environment, things go really crazy. You've got links that are flopping. This entire thing could, under the right circumstances, take the entire cloud down. Now, if we get a distributed denial of service attack that hits any parts of these networks too heavily, it could potentially take the entire cloud down. If we get a distributed denial of service attack and it actually hits any part of the control plane, we can lose the entire cloud. So these are the kind of failures that actually exist and why they actually exist. Now, there's one other thing we should talk about. Scale. Under normal circumstances, most systems work under most conditions. Now, when you get things at scale, that's where you really find out what's wrong. And, that's why if you work with a David Lithicum or a me or a Russ White or an Ivan Pepelinjak that's only done this big, scary stuff, we know all the weird places because it's going to break, because when you get to scale, things just tend to break. So kind of hope that makes a little bit of sense of why things are more likely to break when they get to scale. Now, what I also want you to understand is these are big systems. So imagine you get an issue in one of these systems in this region. DNS, for example, like with AWS. So DNS only it affects a lot of things because that's the way if you use a DNS name for each system, things are going to get bad. And for example, if it says Mike needs to reach Cindy this way by Cindy's name, and I can't reach Cindy because the DNS system is now that I can't reach her, which is one problem in itself. But what happens when systems try to start reaching each other and can't, or they get a bunch of half-open TCP connections or weird things? Well, the next thing that you see is other problems occur, which is why, for example, AWS yesterday just had they had a DNS outage, and then hours later they have all kinds of problems because once one part of the system is affected, big and bad things can happen. But I ask you this. It's no different than a person. If somebody's healthy and all of a sudden they fall and break a hip, and then they have a pneumonia, and then they have this problem and this problem. And that's what happens is the simple things that we normally naturally see aren't actually the big thing. So as architects, we need to plan these things and plan them a lot heavier. So I kind of hope that actually makes sense. So that's the way a cloud provider is built. And that's the way a cloud provider can fail. So does this mean we should always go multi-cloud? No. It means we need to think about what our business needs are. So, and there's trade-offs between multi-cloud and not multi-cloud, and you need to be aware of what they are. So we need to think about, what those trade-offs are. Now, the reality is if I stick you on a single cloud and all you do is you use the cloud provider's native tools, it's really easy. It's kind of the easy button. Click this, and it all works. Now, I love the simplicity and elegance of a single cloud provider. But the reality is, should we be using those simple and elegant things anyway? And here's something that I'd like you to consider. The cloud provider makes jack of all trades stuff. And I'll give you an example. So if by comparison, you can use something that's purpose built or you can use something that's good enough, the question depends on what your actual needs are. So let me kind of walk you through 3 situations that I'd like you to think about. And we'll talk about what the difference between a purpose built tool versus a Swiss Army knife tool like a cloud provider. And I'll give you 2 examples and then I'll give you a cloud provider. So I want you to understand what we're giving up and what we're getting instead of not using a cloud provider's tools. So I like to cook. I cook Greek food. My mother-in-law taught me how to cook Greek food. My father-in-law had a Greek restaurant and a diner. So they taught me how to cook, and I love to cook. Now, when I was younger, before I hurt my foot, I used to love to go to walk, and I always carried a little Swiss Army knife with me. And I got to tell you why. You know, for some reason, I tripped and fell, and I needed to make some kind of a splint. I could do it. If for some reason I needed to open a can, whatever, and I found out I forgot my can opener, I could do it. So I always thought that was cool. Now, when I got home from my walk and I wanted to go cook for my wife, I pulled out a chef's knife. And the reason is, you know, a specialty device that's made by a specialty organization is not the same as that jack of all trades things. And I'll give you an example where the cloud provider where what you're giving up is nothing. Now, let's talk about another situation where you might actually use more industrial tools than something else. So let me give you another example. So I'll give you an example from my youth. Now, when I was younger, I worked as a firefighter paramedic, mostly a paramedic because I'm not too good with tools. I'll admit that I'm not handy. So they called me a Band-Aid pusher and kept me on the ambulances, and I was quite happy with that. So you can go to Home Depot and buy any pair of pliers you want. Any pair of pliers you want. General pair of pliers. Now, the people that knew how to use the tools on the firefighting team, you know what they used? They pulled out this Hearst tool. You may have heard of it, called the Jaw of Life. And they used to rip the doors off the car and rescue people. And they did it really well. And that was a purpose-built tool. And then I seriously want you to really think about when we use a cloud provider's tools, they are not purpose-built tools. So here's an example. For example, let's say we wanted to secure our systems. We have 2 different firewalls over here. We've got this AWS WAF on the right side. And to be fair, it does some kind of web application firewall things that are good. Now, here's what it can do. It can protect against known attacks. Great. So I trained you in a martial art and I trained you in self-defense things. And if I attack you exactly the way I trained you, you're going to be able to defend me. But if I attack you differently, the hack goes through. Now, that's what you get mostly from most of your cloud providers' primary firewall. Now, by comparison, I can not use the web application firewall native to the cloud provider, and I can use a more industrial thing. I can go to Palo Alto and get an enterprise-grade firewall, hardware and software. And not only can it do everything that one of the AWS firewalls can do, but where the AWS firewall says, oh, you taught me a choke defense, and I know how to deal with the choke defense, so I'm safe today. And all of a sudden over here, something big happens it can still deal with it because these types of enterprise firewalls have some AI in them. And they start looking for patterns of behavior that don't seem right. And in many cases, they can stop an attack automatically. So what are you giving up when you don't use the cloud provider's native stuff? Simplicity and elegance and jack of all trades stuff. So I never really felt like you were losing a lot. So instead of using some Amazon Aurora, use Oracle. And the reason you use Oracle is not only is it a more industrial database, it's got greater features, but it has multi-masters, which means you can have a master database in multiple clouds. Instead of using DynamoDB, which is proprietary to AWS, you swap that out with Apache Cassandra or MongoDB. By the way, Apache Cassandra writes to all nodes, and you can stick it in 3 clouds at the same time, and it synchronizes. And there's lots of reasons. So keep that in the back of your mind. So from an elegance perspective and a staffing perspective, let's talk trade-offs. A single cloud provider is easier to find. It is much easier to find because in many cases, if I have a multi-cloud architect, that person has to understand the network and the data center. They have to understand where the breaking points are, where the weaknesses in the system. They can't act like a robot, like, oh, I'm excited by this vendor. I like this vendor. I'm biased to this vendor, and I'm just going to use this vendor stuff. Now, honestly, I don't think those people have any place in the world. I wouldn't go to my doctor that only wanted to prescribe drugs by a single company because they had stock in that company. And, that's what happens when you're biased. I want a doctor that would give me anything it takes to save my life or save my family member's life. And when I used to be in internal medicine in my youth, that's what I did. I didn't have a single vendor that I prescribed for my patients, and the same thing for as an architect. Back when I was a nurse practitioner, that's what we're talking about. So kind of keep that in the back of your mind. That's what we're really talking about. We're going to lose the cloud providers' native tools. We're going to lose the cloud providers' IAM tools. So what? We're going to get more capability out of an Okta, for example, than we're going to get out of an AWS or Azure. We're going to use more things and more material things. So I want you to think about what that means. It means when we use the cloud provider, we use their infrastructure. And I'll walk you through a couple of those architectures because there's possible ways you can do that. We use their data center. And we use the things that are best, the infrastructure. And we get rid of those cookie cutter, average, ordinary things that don't work across clouds. And I'll show you why we can't use the AWS WAF, why we can't use the DynamoDB. And I'll show you if we use the DynamoDB, if you want, the complexity and the technical debt that it'll add later, and how we would need to use middleware between systems if you want it. So I want you to understand that. Now, let's also think about the extra staffing. You need better staffing, and there's a cost to the better staffing. But let's get rid of the other multi-cloud myth. It costs twice as much. Now, I want to make sure everybody understands this. Do most of you buy eggs from the grocery store? I eat a lot of eggs. So, it is not more expensive if I want to buy 3 dozen eggs a week to buy 2 dozen from one supermarket and 1 dozen from another supermarket. It doesn't cost twice. It's the same price. Now, it doesn't cost twice if you have 5,000 servers and you put 2,500 in AWS and 25 in Azure. You're just splitting your load. Now, you're increasing your staffing needs. You're increasing the complexity because you have to use more industrial tools, but you're not there. So first principle of multi-cloud architecture is you can't use the cloud provider's native stuff in many ways. So you lose some of the simplicity and some of the easy button in the cloud. This will slightly add to the cost, and it will add to the complexity, which means you need much better people. And you know what? Let's stop there. We'll pause for a couple of sets of questions, and then maybe we'll get some fun. We'll get geeky. We'll start designing clouds, and we'll talk about the pain points and the failover points and what to move and why to move. And of course, before we do that, what kind of applications need multi-cloud versus what kind of applications and business systems do not? So let's see if any questions popped up.
Hey, Mike, just wanted to pop in. Next time you go to your slides, if you could try and pinch out a little bit more. I know that we're not missing anything on the edges. Just the audience feels like we're missing some stuff.
Okay. So, okay, I'll minimize it.
All right. So let's get to the questions.
So the control plane is the major component here for smooth functioning. The control plane is everything. So here's what I want you to understand the control plane. If you've ever had the privilege of watching an orchestra, I love music. I love to watch orchestras. I don't get to see it that often, but here's what you see. You see the most talented musicians probably in the entire world. And then you see a conductor, start, stop, louder, quieter. And that's the conductor that's basically telling those musicians what to do and how to do it. That's orchestration. So the control plane is telling that. If we had no conductor that was saying play softer, play faster, play this, everybody would doing things on their own. And so that's the control plane. So if you need to get your data from point A to point B, let's say we have to cross 3 routers. We have 2 sets of planes. We have the control plane, which determines how to get your traffic from point A to point B. And then we have the data plane, which is how your traffic moves. So in the cloud, we have the same thing. We have the control plane, which determines where your stuff is going to be, how your auto scaling would occur, how you would create things, remove things, what have you. And then we have the data plane, which is the underlying servers and storage that actually makes it actually happen. So that's the key. If the control plane goes down, you've got nothing. And actually, you know what? Let me kind of whiteboard an example on that, because I think it's such a good thing. And let me show you, for example, and let me just draw one slide. I think it'll be fun. So, and hopefully hopefully we can use this as a test to see if I've got my slides minimized, so everybody realizes that we've got 100% of what we need. And we try to get that as big as we can. Okay. Without there. So let's say we have right now, and here's the importance of the control plane. We've got cloud A, and we have cloud B. Now in cloud A, we have 1,000 containers running. And in cloud B, we have 1,000 containers running. We're running 50-50 right now. And because we're running 50-50, if this cloud were to go away, we need 2,000 containers. So this 1,000 containers would have to become 2,000 for Kubernetes to, say, be self-healing or cloud auto-scaling to work. So let's talk about two environments. In environment one, I own the Kubernetes control plane. And we've got Kubernetes control plane servers. And you can see how this happens in action. So in this option, we have our own managed Kubernetes service. We probably went to IBM, got Red Hat, IBM Red Hat, got OpenShift, and we put it on 2 servers or 3 servers or whatever in both clouds. We need an odd number. And now all of a sudden, this cloud goes away. Oh, so I don't lose it, let me just draw a line through it. This cloud goes bye-bye. Now here's what's going to happen. The traffic is going to hit here, usually via DNS failover, but whatever the point is. And all of a sudden, these containers are going to be busy. They're going to be at capacity, and the control plane is going to say, oh, auto scale and take those 1,000 containers over to 2,000 containers. So the control plane determines that. Now let's talk about if we made a mistake, and this would be the huge mistake, and I've seen people do this. So they decide they're going to put their stuff in 2 clouds. Then they're crazy enough and they use the AWS control plane. Now here's what happens. So if they're using the AWS EKS service or control plane to run both clouds, and it will work completely. Now here's what happens. If this cloud goes down, that's using the Kubernetes control plane, EKS will say, oh, we lost capacity, go scale out to 2. That's great. So that one works. But now let's work through what would happen here if the AWS cloud goes down or the EKS service goes down, for example, at AWS. Well, if the EKS service goes down at AWS, you've got a problem, because none of these containers can scale in or scale out, and none of these containers know how to scale in and scale out. So whatever's running is going to stay running, but nothing works. Now, if the AWS system goes down, EKS goes down, and their containers go down, now guess what? Whatever's running here is running, but it's never going to scale to the 2,000. So the control plane is the piece that does that. And our body, our nervous systems are the control plane. So we start to run, for example, our nervous system says, we're running low on oxygen, breathe faster, your heart speeds up. So our nervous systems work very similar to that. It's the control plane of our body. Something happens with our brain or spinal cord, we're in serious trouble because that's our control plane. So the control plane runs something. The brain tells your hand to move. This and this stuff is the control plane. Now the muscles that move it with force, that's the equivalent of the data plane. Great, great question. Listening to this presentation, it appears a solid background in CCA will minimum be of great assistance with routing protocol knowledge employed at scale. Networking skills seem non-emotional. So networking knowledge, yes, but you're not going to get it in the CCNA. I mean, you'll get some of it, but not what I mean. So in a CCNA guest, they're going to tell you how to configure the router. For example, you go to a sister router, you type config T, you go to the interface, for example, interface gigabit 0/0. You put an IP address with a command like IP ADDR 192.168.1.1 mask 255.255.255.0, no shut on the interface, and then turn the routing protocol on. Now, what that will teach you? It will teach you the commands of how to turn something on. Now, as a multi-cloud architect, I don't need you to know how to the commands to turn something on, because you're never going to touch the technology in your life as an architect. What I need you to understand is, where's the routing protocol going to break? For example, in the CCNA, they don't talk about the interior gateway protocol, OSPF, very much. They won't talk about the type of LSAs that you have, where those LSAs exist, how the router calculates a path off of those LSAs. It won't talk you where you run into the maximum level of LSAs and where that's going to break the network. Now, if you're any of architecture programs, we will, because you're going to need that for the job. But there's that's the difference between engineering. For us as architects, it's knowing BGP. It's knowing how to load share across two links, not knowing the commands. It's knowing why we can't take in a certain set of routes and what it could do to our system if we did. So do you need to know networking? Absolutely, absolutely, absolutely. You can't be any kind of a cloud architect without knowing networking. Quite frankly, you can't be any kind of cloud solutions architect without knowing networking. But it's not the hands-on how-to, it's the actual design. And I know most people don't get the difference between the two, but I want you to understand, the person that designs the shopping mall or the person that designs the building. For example, on one of the last trips I had to Dubai, I got to stay in the Burj Al Arab. It was the most beautiful hotel I've ever seen. It was incredible. Now, it was designed by an architect, but it was built by construction people and engineers. It's the same thing we're talking about here. So hope that kind of helps. You have to learn how to design it, and you do have to learn networking. Given the AWS downtime yesterday, does it make sense to have multi-cloud? Well, it depends. So here's what we really need to talk about, which is what I was going to talk about next. Let's talk of two different situations. Situation one is, I have a non-critical application. For example, if that application's down for 2 hours, nothing matters. Now, by comparison, I have another application, and that application is for a bank, and every minute that application's down, it costs $1 million. I can't afford to keep that in one cloud. That's too risky. So we have to look at the applications. We have to look at the service, the criticality of the business, and then we can determine what level of availability we need to build for. Great, great question. Well, I'm going to talk about that a little more. Any others? As a cloud architect, we have to understand trade-offs in using tools, purpose-built tools or cloud provider tools. What's the best choice and which do you recommend? So great question. As an architect, we're not really recommending tools. We're recommending strategies. Engineers are using tools for the most part. For example, if I'm going to create a zero trust strategy for an organization's security, and if you don't know what that means, please take the free Security Fundamentals Bootcamp. But if I need to create a zero trust strategy, that strategy is going to take certain types of things like context-aware IAM. Now, I don't care who makes it, but we can evaluate the strengths and weaknesses of each product later, but I know I might need context-aware IAM. Now, I know that I need a strong encryption strategy, so I need a very strong key management system or approach to that. Now, I know I need to micro-segment, so with that, I need to know that I need some kind of micro-segmenting based upon identity, but also ideally some kind of micro-segmentation based on a network. For example, whether it's an access control list, a firewall, breaking a cloud into multiple VPCs or VNets and not routing between them, for example, using some other flavor of segmentation like a control plane, like in AWS organizations, that kind of thing. So Giston, I really want you to come to our How to Become a Architect webinar, the next one, because we'll go over what we do. We'll talk about the skills that you actually need and make sure you understand the difference between an architect and an engineer, because most people fail the architect interview because they came with engineering skills, not architecture skills. So what do we do? It's just like when I used to practice medicine. A patient would come in when I was a nurse practitioner and they'd have a disease or an infection, and I would look at them, I would examine them, and based upon their condition, I would say which would be the best medication and roadmap, because different things that they might have, for example, asthma might change which blood pressure drugs I could give. or high blood pressure might change which pain drugs I could give. So that's what we have to do. We have to analyze the business, understand where the business is going, understand the business's challenges, and then we can recommend technology, but we need to know the business first. These are great questions coming in today. What applications need SASE? Well, SASE is not required for anything. SASE can be a very good option when you're dealing with a lot of remote access users, for example. So if I had a multi-cloud versus single cloud, would I use load shadowing or failover? It all depends on the business needs, Andrew. All in all, I'd probably in most cases prefer to load share 50-50. Because if I load share 50-50 and I lose one cloud, the other one just goes to full capacity and it's an automated failover, and I can go from disaster to fully up and operational within 45 minutes or less. So typically speaking, that's what I would go, but it depends. Let's get to the next question, Andrew. What are my thoughts on building AI agent architecture to back up and build multiple control planes? When we're talking about a control plane, this is going to be far more sophisticated than an AI agent is going to take care of. We're talking about, to make these kinds of control planes, teams of thousands of developers and AI a year or so. So we're not going to fix that in a few minutes. But wonderful theory. What stops the cloud provider from placing purpose-built devices that will door their data center? They do. They're not going to use their stuff to purpose. They're going to use real hardware devices that are actually doing it. And a cloud provider in just a single cloud can choose to use that as well. But they're going to have to pay for a firewall anyway. And one second, trying to see the second half of this. And that's the thing. But the question is, does the cloud provider recommend those other things? Or do they recommend their own because it's more profitable to recommend their own? So nothing stops. So for example, when I worked at Cisco, when I was a solutions architect, it's all about the Cisco product, because the solutions architect's not really a trusted advisor role. It's a pre-sales role. Now, at some point, Cisco moved me into a chief healthcare architect role with an enterprise architect role. And now I was to be an industry trusted advisor. And that meant I needed to know where the industry was going, shape the industry. And it was, well, Cisco has this tool, but you know what? This provider has this tool, and we strongly recommend it for your business needs. And it's a very different position to be in when you're not tied to sales and you're not compensated via commission, that kind of thing. Great question, Fred. Raja. What is the scope of the control plane? Does it typically operate within a single data center, or can it span multiple data centers? So, Raja, that's the actual problem. The control plane has to be in each data center and actually talk to each other. So what I really want you to think about that is, so let's say you got 3 people in the house and they're all in separate rooms in the same house, and then somebody gets the flu. Now, I got to tell you, one room gets the flu, no matter how careful you are, the next room gets the flu, the next person gets the flu, and it all happens in the same house. So the point is yes, we need to have those control planes in each data center, because if one data center fails, the other ones need to have a control plane that stays up. But those control planes actually need to talk to each other. So you have to worry that if and when something happens to a single part of it, when does it take down the entire control plane? So it's something to plan around. That's the strength and the weakness, Raja. Chris, let's go to the next one. How do you keep costs down with multi-cloud? Well, here's something to think about. And we're also going to talk about why organizations use hybrid cloud, multi-cloud. What if I told you that the compute capacity that we have, we bought the servers from Amazon. They're now $400 each for the server. And we bought them, and for 10 of them, you could buy them for $4,000 one time. What if I told you that to rent those same servers on AWS as an on-demand instance would have been $11,000 a month today versus $4,000 I could buy one once? So when you're dealing with a lot of compute capacity and high throughput, don't put it in the public cloud. A $300,000 from Dell could cost upwards of $5 million on an AWS cloud over the course of 4 years. Now, by comparison, there's some things that I don't want to build for in the data center that are going to be more costly in the data center, more sporadic workloads that I want to use the cloud. So the whole point of using multiple clouds is might be cheaper for this one service on this cloud. This cloud provider has the lowest options that we can run a batch compute job or an AI learning job at night. That's why we go there. So Oracle might be cheaper on AI, so we use Oracle for AI if we don't need the high availability. We use AWS for capacity and Google to back it up. So that's one of the ways we actually do it. But also important is to know is what we put on the cloud. Now, the good news, LabAche, is when you're generally designing a multi-cloud architecture, you generally have more sophisticated people that are designing it. And when you have very sophisticated people that design it, they've done all the planning correctly. They know exactly the capacity their systems are using. They compute DRAM size. They know how to right size the instances that they actually use on the cloud. So they're actually designing a better architecture because they have to be more detailed to make it multi-cloud anyway. So in many cases, that actually cuts the cost down, that extra due diligence of having someone that really knows what to calculate for versus someone doesn't know. So they calculate it and they have what calls the fudge factor. Well, I think I need 20, but I'm not sure. So let's add another 10. So you're paying for 30 when you needed 11 if you actually knew. So that's the difference, and that helps. Great question. How do you evaluate which workload should remain on-premise versus migrated to a public cloud or multi-cloud? Generally speaking, I actually look at it. For example, a high security workload, it's much easier for me to do in a private data center than the public cloud because I have much more control. A low latency workload, well, it's a lot less latency to, if I have a campus of say 10,000 users, to put my data center directly where the users are. They'll have a much better experience, no wide area networking cost, higher performance, and lower cost. I've got a big high throughput workload. I'm not going to stick that on the cloud because it's going to be 10 times cheaper to put it on the data center. Now, all of a sudden, I've got this workload that's very sporadic. It could be nothing or it could be huge. That's something I pop on the cloud. Or I don't have a team of people that are sophisticated enough to manage a data center and I can't hire them and I don't want to focus on it, go straight to the cloud. Or I have 10,000 developers inside of our organization, and my developers know nothing of networking, of infrastructure, but they're super smart and they can write code and they're among the best of the best at code. Well, now they clearly can't manage the infrastructure, but they could do well with the cloud environment. So I have to think about all those things. Great question. Let's go to the next one. How do you balance cost optimization with performance and resiliency across multiple cloud providers? That takes about 1,000 hours to truly teach that, which is why we have our architect program. But at the topical level, what I can say is it doesn't have to cost more. If you truly know what you're actually dealing with and you truly place your workloads in exactly the right place, it doesn't necessarily cost more. It could, but it might not, and it all depends how you do it. And the reality is, here, cloud provider, I'm exclusively with you. Okay, here's your discount. Here, cloud provider, I'm going to put 50% in this cloud provider, unless you give me a discount. You might even negotiate a better discount, or or use the cloud providers to negotiate each other with them. I got this offer from this one. Will you meet it, match it? So the key of having multiple sources and negotiating from a position of strength, specifically pricing, is a good thing. And depending upon potentially making press releases and cases with them, you can potentially also negotiate a bigger discount if you're a big client that's got a big brand that could be valuable for the provider. And I've also helped clients with that. Great question. Let's go to the next. What was the main cause of the outage yesterday? AWS said it was DNS. But we don't always get the most clear and accurate definitions of what the cause of the outages were from AWS. For example, I can remember when they had a pretty serious global outage. It started in US, and so I remember when they had a really, really serious global outage, and it was around, I think it was December of 2021. And AWS blamed it on an impaired network. Now, and that was exactly their words, was impaired networking when they published it. And I was wondering, did a router and a switch go to the bar and get drunk? How did they become impaired? So their answers are never really anything that's going to satisfy you. Like if you really looked at it, and I think the answers that came out that in that year that were so bad, in 2021, there were about three. There was 2020 or 2021. There were about 3 AWS outages that occurred in a short period of time. And the answers to what they told us, to anybody that knew tech looked at it and was like, I don't know. And then we got other people like Azure who just says, hey, we've been hacked. And we've been hacked again. And they tell you what their outages are for. So we don't know why some of these cloud outages are necessarily go on. We can say that they say it began with DNS tomorrow, and I have to take what they say as accurate, but I wasn't there to actually know. Good question, though. Yes. I don't believe that bigger companies like Snapchat and others don't have resilient architectures and rely only on a single provider. Well, Ahmed, you found out yesterday that they did, of what there were. Now, Capital One is 100% on AWS, which terrifies me. But you don't really hear about JP Morgan Chase going down, do you? When was the last time you heard about Wells Fargo having a big outage? So they all use some cloud services, but they all have multiple data centers and have real resilience architectures. So it all depends on how sophisticated. But, look at all those companies that were severely impaired. We use software as a service providers like any other business. And because of it, we keep backup service providers for video streaming. For example, we use Restream primarily, but they were down yesterday because of an AWS outage, but StreamYard was not. And lots of systems have been down. You'd be surprised how many people have put themselves on a single cloud and how many big outages have actually occurred and how many big names are actually there. So there's a difference between a resilience plan and a real resilience plan. And unfortunately, not everybody is fairly sophisticated. For example, 80% of the people that use the cloud get no financial benefit from it whatsoever. And the cloud is a very valuable tool. They're just using it wrong. And in my 25 years as an architect, I have to tell you the majority of issues that I've seen were people that had a plan, but they didn't really understand the technology well enough to design it correctly. And the plan didn't really work and they didn't test the plan. So I'm with you, Ahmed, but they should, but not everybody's too good at what they do. Let's get back to the content. So let's talk about which things need multi-cloud, and then we're going to start designing it. Let's say you've got a very important business, a big business, like a hospital. Let's say it's a very large medical facility. Now, in that hospital medical facility, there are a lot of things going on. There are the electronic health records, which covers the entire patient information. Now, if that electronic health record goes down, nurses, doctors, pharmacists, they can't see anything what's going on with the patient. That's a problem. Now, likewise, for that hospital, they have some medication systems, some pharmacy systems, and some patients might need their medications. And if we don't know what it is, that could be pretty dangerous. Again, somebody could die. So those kind of things have to be high availability, meaning hybrid cloud, data center plus cloud, multi-cloud, 2 clouds, or something to that effect. They have to. Because if those applications go down, somebody dies. Now, what if the hospital has some wellness classes, some meditation classes, some yoga classes, some community exercise classes, and they post that on a web page? Now, if that website goes down for the community yoga classes, well, I'm going to be cranky and get my yoga in for the day, but nothing else is going to go wrong. So the key is we have to look at our applications and tier them. We typically have this gold platinum tier, which are applications that are so big. Imagine a company like E-Trade, for example, or any large, trading firm where you couldn't actually go to your bank and place a trade when you wanted to. Yesterday, you bought a lot of a stock. Today, it's crashing and you want to sell it and you can't. That is a major nightmare. So a trading application for a bank can't go down. Robin let themselves go down. Yesterday, they were down. Now, JP Morgan Chase wasn't down because they're responsible. But we have to actually look at the quality of the companies and what needs to occur. So some things need to go down. How about your internet service provider? I have AT&T fiber to my home. It's not high availability by any stretch of the imagination. I've had 6 hours of outages already this year that I know about, let alone the ones that I don't know about because they occurred when I was sleeping, but they literally affected me. Now, if I spend 10 grand a month from a line from New York to London, I expect it to be there 99.9% of the time or greater, or ideally 99.99+% of the time. So I kind of hope that actually helps. So that's what we're actually talking about, is being able to figure out what they are. Some applications don't matter. Now, one day I'm going to make a website with photos of my cat, Cindy. I love my cat, Cindy. I adopted a cat for my wife. Had no idea that cat was going to sit on my lap and never go away and then sleep on my head every night or in here every night, follow me to room. And the next thing I know, I'm a cat cuckoo that loves cats so much. But, if I made a photo of my cat and her beautiful things that she's done, I'm not going to put that on two clouds, because if a cloud provider goes down, it doesn't matter. Now, if I take the emergency call system, the 911 system in the US, the 999 system in the UK, and you need to dial for a 911 because you need an ambulance, or 9999, depending upon which country you're in, because you need a police car, and they don't come because they can't answer the phone, that needs to be multi-cloud. So that's what I really want you to think about. And how do you do that? Is it life and limb critical? Well, yeah, obviously that needs to be multi-cloud. Or look at the financial impact. So we're always, as architects, going to have to do some flavor of a business impact analysis. If this website goes down, what does it cost us per minute? How many minutes can we afford to be down before we have irreparable damage to our actual business? If we are down, what does it do to brand damage? If we are down, what does it do to trust? Do people trust us? Now, I wouldn't trust a financial account in Robinhood if it went down because they were in a single cloud and it went down. I'd be pulling my money and moving it somewhere else. That would terrify me. Now, I'm not saying there's anything wrong with Robinhood, but I wouldn't ever want to be in a position where I couldn't access a trade that I was trying to deal with in a financial environment. So if I had an account like that, I saw that, I'd move it to another company that wouldn't be that way. And not many businesses are like that. So that's what we really have to consider. So let's talk about how we make this work. Let's talk about what goes into a multi-cloud architecture. And, well, you know what? Let's have some fun. Let's make it a hybrid multi-cloud architecture so we can really optimize it for speed. We can optimize it for cost. We can optimize it for performance and latency and security along the way. So let's have some fun with this, because I want you to really get to see what we're actually dealing with. Okay, so let's go create a little whiteboard out of PowerPoint. So let's say we have our own private cloud to a degree. So we've got a campus with 10,000 people in it. And on the campus, we've got a very large room filled with lots of servers and whatever. So this is our local data center. And I'm going to first show you the cool stuff we could do with this hybrid cloud. And then let me change this to red so I can make it empty. Okay, so we've got a campus with 10,000 people. We've got our data center that is sitting over here. And what we do is we install in our data center, let's say we take Nutanix. And Nutanix is a cloud control plane that you install on your servers. And that way you have all the things that you could do in the public cloud. Want to launch 5,000 virtual machines with an infrastructure as code script, like a Terraform script? You send it to the Nutanix control plane. It does it to your data center. Need additional capacity, and you've got the software load balancers, and you want extra VMs or containers. It's all going to happen, and it's all going to come out of the capacity in your data center. Now, what I want you to understand here is this, I can literally do this in a data center, and I can't do this in the public cloud. I can have on my network on the same switch. So let's say this is, so I can have on my network on the same switch. So let's say this is all in a single VLAN. A VLAN is a virtual LAN. It's a part of a LAN. I can literally make it inside of the VLAN where everybody is on the same subnet that this one server can't talk to another server in the same VLAN. And I can, and obviously, unless we enable routing between them, if we have two separate VLANs, none of these servers from here could ever talk to this unless we route between them. And we can make it that this server can't even talk to this server. And we can do that at layer 2 or at the MAC address level. We can also determine who's allowed to get on the system or not by plugging in and seeing if they're allowed to be. Now, well, what I can also do here, and I would definitely do it in any high security environment, is I can make, if this server gets infected with a worm, for example, or this server could be spewing traffic at 100 gigabit a second and take down my entire network. But, and you can't do this in the cloud, but in a private data center, I can limit the server to a certain amount. So if this server, for example, does something cuckoo, I can make sure that the server is not allowed to take down my system because I have these controls. You cloud provider can't offer this because they don't know what your servers are supposed to do. It's a shared system. Now I can make it obviously that these things can't talk to each other. These things can't talk to each other. And you know what else I can do? I can say that this server, let's say this server has voice. This server's traffic is prioritized over this server's things that are related to non-mission critical things. So I can add a level of protections that you can't even imagine in the private data center that I can on the cloud. This and many other things. I lose these things when I go to the public cloud. So I need a new security paradigm like zero trust because we're in a much weaker environment. But let's say we have this campus. By doing it this way, I've got my full cloud. Now I have the opportunity to do two things here. And this is going to be the cheapest of all the multiple cloud architectures is this. Now, if I could do that, I have two options here. One is this is typically the cheapest for most organizations that need capacity on demand. So I put maybe 2 Nutanix servers here, 3 physical servers, or I just get some rental servers and we put Nutanix control plane on them. All of a sudden, you know, my system's running good here. I need additional capacity and I could add capacity on demand on the cloud provider, either with AWS native stuff or Nutanix. So think about this. My data center's humming along. It's running great. I build it for average need. And let's say we sell stuff as an e-commerce provider. It's here. I'm running cheap all year long. Now, all of a sudden, it's Christmas time where everybody buys stuff or whatever holiday of your choice. And then additional capacity comes to the cloud provider. This is the cheapest because the workloads here are the cheapest. And why is it always going to be cheaper in your data center than a cloud provider, or almost always? Well, the cloud business is a landlord-tenant business. What does that mean? It means if you don't buy 5,000 servers, the cloud provider has to have those same 5,000 servers to support your needs. Now, you maybe pay $3,000 for $100,000 for the server, and maybe they pay $250 because of an economy of scale. Now, there is that. So they get it slightly cheaper than you would. Now, they're also at hyperscale, which means they need twice as many people or 3 times as many people because things go wrong. And at hyperscale, things get more expensive, which is generally why a huge organization or a government can't do things as efficiently as a small business. But they can do many other things and huge things. Being bigger just means being a little slower, but being more controlled, more standardized processes, what have you, because you need that. Being smaller means more nimble, but you can't get as big as stuff done. So there's trade-offs to every architecture you could ever look at. But you know, that's really the thing to think about, is we figure out what we need and where we need it and what capacity and where and what's important. But if it costs you $5 million to run a data center, chances are it costs them to say $5 million. Now, they have to hire an army of salespeople to sell you the stuff, right? And they've got tens of thousands of solutions architects being paid a couple $100,000 a year and sales rep being paid a couple $100,000 a year. Then they have marketing teams and advertising budgets and all of this. So the costs go up 2 to 3 times more than the average cost. On average, it's about 2.7 times. That was David Lithick's number, more expensive on the cloud than the data center, because they have to run the same thing and then they have to make a profit on it. Which is why if you stay at a hotel, it costs less for the hotel owner per your room than it does for you. Which is why if you rent an apartment, the landlord will be paying less per month than you will be, because this is a landlord-tenant business. So understand your cheapest, almost all the time, not always, but most of the time, is this hybrid cloud. Now, the key to remember with this to maximize success is high throughput, high power stuff goes here. So if you actually look at where the data center spending is going on right now, it's actually, most of it is businesses buying their AI type stuff, or cloud providers buying AI stuff. But the AI workloads are typically cheaper in the data centers. The big high powered compute things typically cheaper in the data centers. The event driven stuff typically cheaper in the cloud providers. So we have to think about that logically. So this is going to be the easiest. And this is going to be a highly redundant, because we've got 2 clouds effectively. This is going to be your highest performance stuff here, your agile, your scalability stuff here. And many businesses do this. Kind of look at like JP Morgan Chase. They used to talk about saving $2 billion a year by not using a cloud. Now, they still have their data centers, but now they put some AI stuff over here. So the best companies are being strategic about where they put their workloads. Best performance, best security, lowest cost. Now, the alternative is, I just want you to see all the options. The alternative is this, and this is what you're going to see a lot of. Quite frankly, this is most of what I know and see, is you typically see this, where you've got wide area connections to one cloud provider. You've got wide area network connections to the other cloud provider. And obviously, this is not on the same service provider as this. So this might be a link on AT&T. This would be a link on Verizon. And typically speaking, we'll have more than one link for these 2. They'll be redundant, and of course, across providers. But the point this way is we can reach our systems on one cloud provider. We can reach our systems on another cloud provider. And any cloud provider can go down. It doesn't matter. Now, why might we do this? So the campus in a single cloud provider is high availability, but let's talk about this. So let's look at YouTube. There's a reason I'm picking YouTube. Did you notice that YouTube almost never goes down? Did you notice that? And did you notice that even when there's a Google Cloud outage, YouTube stays up? Anybody know the reason for that? Because most of YouTube is not on the Google Cloud. Google uses the Google Cloud for analytics and a whole bunch of other wonderful things that benefits YouTube. But most of the YouTube infrastructure is not on the Google Cloud. So they use the Google Cloud where it makes sense. It makes sense to have purpose-built video distribution data centers like YouTube does. It's an incredibly smart architecture. Incredible what they've done. So, but if you notice what they've done, data centers for this, and for the analytics, we're going to use the really cool tools that exist in the Google Cloud. So think about that for a second. So think about this environment where, let's say, data center 1 may have some better models for analytics. So let's say we're in this cloud for analytics. This is not high availability here. It could be. So let's say we've placed our analytics here. Let's call this Google.
Mike, you're not sharing.
So let's say we placed our analytics in Google, because they're great at it. Put our analytics in Google. For some reason, Oracle gave us some really great AI pricing. So we put our AI in Oracle, and we have this mission critical application that's super mission critical. In fact, it's a life and death application for a large hospital system. Well, honestly, if it's that important, we put the mission critical app in two or all 3 clouds. And that's how we don't get into a mess of things that are overly expensive, is we determine what we're placing where. And this is typically why, this is the reason why 98% of enterprises are multiple clouds, because Google's going to give them something that they have that Google's done that Google's really good at, that's been critical to Google's business. And usually Google has some very interesting AI type things. And then Oracle, well, they're an AI, or it could be, or analytics things. Well, Google does that good with both, but Oracle's really built a purpose-built AI cloud. Now, let's say you're dealing with a healthcare organization. Oracle owns Cerner, an incredibly huge electronic health record platform, and they have a good 1,000+ medical people. Cerner used to have 1,300 clinicians when I went there many years ago. So Oracle has a lot of healthcare expertise. So now if this is a hospital, I might place it here in Oracle because Oracle might have even more experience than another cloud provider. So that's what we really need to think of, what's mission critical and what's not. So let's talk about how we would do this. And then we can actually build up, we can put some applications here, but let's look at how we do this. So we've got a cloud, let's say this is cloud provider A. And this is cloud provider B. What happened to my mouse? Let's walk through some public versus private situations. So let's make this red. Let's get, bear with me. Where's this fill thing? Oh, here we go. So let's say we have a load balancer over here in the cloud provider. Let's say we're an e-commerce provider. So we've got a load balancer in cloud provider A. We've got a load balancer in cloud provider B. And we're not looking at the demilitarized zone and everything where the things are here for right now. We're just, and if you want, I'm happy to draw that of how we would do this from a security perspective. But for right now, let's just put the load balancer in both places. Now, typically behind the load balancer, you're going to have some VMs, right? So you're going to have, say, your web interface VMs. So you'd have your load balancer. And you would typically have some application virtual machines and then a load balancer between these. But let's just use this for right now. Now, this would be a web-based environment. So let's think of this as over here as the internet. And while we think of the internet, I want you to think that DNS is also up here in some way, shape, or form. Because DNS has this hierarchical system. Your DNS servers will talk to this system up here, which will ultimately determine where people will go for their network. So let's just look at this. We standardize, we put 50% of our web VMs here, and we put the other 50% of our web VMs here. Now let's walk through an architectural situation. Cloud provider A is AWS. Cloud provider B is BWS. Yeah, let's have some fun here with the alphabet. So we decided we were going to use AWS Route 53 as our DNS provider. Now the AWS cloud goes bye-bye. This could be any cloud provider of their choice. AWS has outages. Google has outages. Microsoft has outages. They're great at what they do. I don't want you to think otherwise. It's just that the bigger stuff gets, the more complicated it gets, the more it's scale, the more things are going to break. So the AWS cloud provider goes away. If we're using the AWS DNS plan, guess what? Everything we own is going to go down, which is why I don't have a single enterprise client that ever used AWS Route 53. Now I have plenty of enterprise clients that would stick some F5 virtual machines, F5 DNS systems on both cloud providers, and look what happens now. in this particular case, since we used AWS as the DNS provider for, now we have F5. And these servers are telling the internet's DNS how to go. Now, cloud provider AWS went bye-bye. Guess what? All the traffic will be sent over to cloud provider B immediately. Now, if these web virtual machines are in an auto-scaling group, and let's say we needed 10 and we only have 5 here, these virtual machines will scale out to all 10 and we're up and running. What's the expression, Bob's your uncle, where everything's good, and that's where we're going to be. But, and this could happen this could happen the same way. Cloud provider BMS could go away. And then because we have separate DNS, it's going to go here. So the first thing we need to make sure is we're not using cloud providers DNS. We're not using the cloud provider's container control plane. We're using our own. Now, here's the good news. I promise you, you are going to get much better DNS features and functionality from this than the cloud provider would give you anyway, which is why so many enterprises are using this type of service as opposed to using something free. So keep that in the back of your mind. So that's one thing we need to do. And that's how and where this could work. But I wanted to just see where those pointers are. So what's the elegant way that we can do this? And how does this smoothly work? So let's say we've got 3 clouds. Private cloud, believe me, everybody has outages, so it's not like we can blame any one of them. So what you'll typically have is, in order to make this happen, is you'll typically have ideally 2 routers. Actually, you know what? Let's do this at a high level and then let's have some fun with it. We'll actually break it down a little deeper. So we'll have 2 routers over here. And of course, we're going to connect to the cloud provider's virtual routers or virtual gateways. Gateway is just a router. Now, we might be using a direct connect to a direct connect gateway to a transit gateway to whatever, but we're basically just using private lines. Let's make this look a little bigger so it's going to match up. These are routers. I'm just going to connect it with a single line. You can't make a connection without a router, but I'll show you what the routers could and should look like along the way. And then we're going to have, and this would be, say, on AT&T if it's in the United States, and this would be, say, on Verizon if it was in the United States. And they're always going to be on different providers. You can never, ever be on the same provider if you're designing a high availability system, because it's a single point of failure. And here we could still use the same 2 providers or use a separate set of providers, whichever. Now, this is what our network, our wide area network and connecting is going to look like. Now, if we can do this, if we can be very good with our IP addressing scheme, for example, make this the 172.16.0.0/16 CIDR range, and we can make this the 172, let's just come back in here, the 172.17 CIDR range, and that we can make this and we can make this data center in the 172.18.0.0/16 range, and we can be consistent and make sure that we keep these addresses in this range. This routing becomes very easy, and this is going to scale. And the reason is this: we only need to send basically a single route or potentially 2 routes to load share off of these lines. And we don't have to send all this stuff about the specificity about what's going on into here. And that way, if something cuckoo happens over here, we kind of limited the blast radius to a degree of here to here. We could potentially even firewall these off if we want to, and sometimes we will, and sometimes we won't. At the same time, we've got Azure over here. We're going to have the same 2 private lines. We only need to send a single route. So that's going to work from a scalability perspective. So where do you think this stuff goes wrong? And where do you think people design this and they break it all the time? And this is where you would put your mission critical things. So let's build one, design one, if you will. And now let's really look at this. So the first thing I want you to think about is this. Let's say this is you're in a building and it's coming into your building here. We have to make sure that these two links, the AT&T link and the Verizon link, aren't underground inside of the same conduit. Because a lot of times what you'll see is these two links will be inside of a conduit under the ground, and here's the reason why. So you've got a person doing city construction, they dig a hole with a backhoe, and then they cut through the conduit, and both AT&T and Verizon are in the same conduit, and you're down. If this is an internet, so we need to make sure they're coming into a different part of the building in each building that we have, as well as going to AWS, for example. If these two links are going in the same place, which they're not, thankfully, usually, but if they were, and all it takes is breaking that cable, and you're done. So we have to be careful of that. Now, if this was an undersea cable, we need to make sure that, and this was an international thing, we need to make sure that this thing and this thing is not in the same undersea cable bundle where they bundle them, because again, you cut that cable and you lose things. So we have to be careful where they're going into the building, which part, because you want redundancy in that, generally speaking, and redundancy across paths under the ground. Now let's look at devices that are there for high availability, and I'll show you the difference because I've seen these take down really big enterprises. And here's the difference between an industrial grade router and a consumer grade router as a rule. So you may have one of these in your house, and it's got basically you've got an internal network. And then you've got the internet over here. You've got the internet over there. And this is your home router / firewall. And you've got your TV over here. Oops, what just happened there? You've got your television set over here. That's running. You got your iPad. If you're an Apple person, we'll call it an iPad or your iWatch or your whatever. You've got your refrigerator for some reason is now IP enabled. You know, who knows? Your security cameras are all IP enabled, whatever. So these all get translated to a single IP address when they go in the outside world. This is in your house. Now, if this device itself in your house has one power cord and it goes to a single outlet. Now, if the power in that outlet goes down, you lose your network. This device crashes, you lose your network. Power supply fails, power cable fails, you're done. So this does not make a high performance, high availability connection. So what does it look like when we connect to things in a high availability environment? Well, these are what our network devices are going to look like. So if we have two private clouds, for example, and these are the connectivity to our two private clouds, like we own them. I want you to think about this kind of a router, because this is realistically what we're doing. So most routers have a brain. You know how your CPU has a brain? They're called the control module. They are the control plane for the switch. And if it really matters, we're going to use two of these switches because we will, but I want to show you. So the control module is the brain of the switch, the control plane. If this thing goes down, you've got nothing. So what do you use? You put two of these in there. And this is what you'll see in a core internet router, or what you'll see in a cloud provider's routers too, to hope things don't go wrong. Now, here's something for you. Now, we've got this $100,000 router, easy. And this is the power supply. And we pub this power supply into something called a PDU, or a power distribution unit. And these PDUs themselves typically are about, they typically support 6,000 watts on average. 30 amps, let's say 240 volt, about 6,000 watts when all is said and done, a little more than that. So this goes into the PDU, and the PDU plugs into a single outlet, and the PDU has a circuit breaker. What happens if this power distribution unit dies or this circuit breaker blows? Well, then the thing connecting you to the cloud is dead. You've got nothing. So we can't have this. So, and I've seen this happen. So what you typically have on a high availability network device and a high availability server is the same concept. 2 power supplies. Now, I've seen this outage. Don't do this. I've seen people tend to take the second power supply and then plug it into the same outlet. And they feel like they've got it. They've got a good device. Now, this circuit breaker blows, this PDU blows, and their switch is down. And most people don't think of these things. So what do? You make sure you've got 2 power distributed units on 2 different circuit breakers, and you plug your device into something else. Now we're starting to get into high availability network devices. And did I show you that firewall earlier? Where I showed you that the AWS WAF, which had the pretty little graphic of it, versus the Palo Alto firewall that looked huge like this. That's typically what we were talking about, the difference. Now, let's also think about things. So let's say we are going to get 2 10 gig links going to the cloud provider. Because what if the 10 gig link goes down and we need more than 10 gigs? So this is going to be called a line card in a device. Now, in the line card, what do? We have a switch port. We put a little optic in it, which is a laser beam, and then we put a piece of fiber optic cable in there. Now, it's quite possible that this line card breaks, the port breaks, or the laser breaks. So obviously that's no good. It's another single point of failure. So on this line card, we have another line card. So now, typically speaking, if we're connecting 2 data centers, we're going to have 2 of these identical devices on each side, not 1, but 2. And then what we will typically do is we will pump our links across cards. Now, I want you to think how much redundancy actually went into this device, and we'll probably still use 2 of them if it matters. We can lose one of the control planes. We can lose a power supply. We can lose a line card, and we're still talking. So if it really matters, that's what we're going to be doing. We could be taking these 2 links on AT&T. The other 2 devices could be on Verizon, but I want you to think about that. Now, it mattered where the fiber came into the building. It mattered where we were plugged into power. It mattered where we put our line cards. This is just to connect to the cloud themselves. So this is what you would think about some principles of high availability. Let's do this. I think that a lot of questions popped in. So let me stop for some questions, and then I'll get back after we answer some direct questions. Sharon Nibbs. Can you architect a multi-cloud solution using AKS on Azure and EKS and AWS to control and fault tolerance so that if one control plane becomes available, the other could? You could. But now you have 2 sets of systems that you need to manage and 2 sets of telemetry coming in, which is going to add complexity. What most people do is either they would make their own Kubernetes control plane, or Red Hat, which is owned by IBM, has OpenShift. And OpenShift is like the perfect Kubernetes control plane that is managed for you, like the cloud provider ones. And you can stick it on virtual machines and all 3 cloud providers all at the same time. So most people that I know wouldn't take the risk of using anything that looks like it could feel proprietary like that. And they would use OpenStack, typically speaking. I'm sorry, OpenShift. But it would work, Sharon. Is the AWS control plane similar to OpenStack? Very similar. So, a lot of, I always had in the beginning, my students actually build a cloud. Even though architects don't touch something, I still have my students as a general rule build a cloud. And the reason I want them to see it is I want them to see what happens when they go from a server in my data center and they put that control plane, and all of a sudden they've got a management panel that feels just like AWS, Azure, or Google. And then they can use the CLI, the Terraform to do it. So it's all really the same stuff. The only difference is that we're really talking about between clouds is what they call them. So I'm used to calling this Nero because that's what we call it in Greece. But some people call it agua. Some people call it Wasser, say in Germany. But it's all just at the end of the day water. So, lots of people, there's tissues that are called puffs, there's tissues that are called Kleenex, but it's all really branding stuff. It's just different names the cloud provider is using for the same kind of technology for the most part that's 20 plus years old we've been using in the data center. Just virtual version, which usually means suboptimal, but almost as good, but more agile. Good question so far. Chris, are there any others? I think I remember there being a lot. Aladino. When designing a multi-cloud architecture to reduce single points of failure, how do we count for differences in service level agreements between cloud providers, especially regarding uptime? So I plan around the cloud provider service level agreements because I really want you to understand what they are. The service level agreement is that I say to you, I'm going to be available 99.999% of the time. And if I'm not, I'm going to reimburse you a little bit on your bill. So I'm in the cloud. I expect to be 99.999% of the time. I'm a healthcare organization, and I've used 2 availability zones in 2 different regions, and I'm supposed to be 99.999. Now that cloud goes down, and a patient dies at the hospital. There's going to be a lawsuit at that hospital. Plus, we had a patient that died at the hospital, and AWS is going to say, here's a small credit on your bill. So at the end of the day, I do take these SLAs as important, but it's very hard for anybody to truly promise you anything when there are factors outside of their control. It's not in their control if they get hacked. It's not in their control if a big state government decides to hack a single cloud provider. They can do everything right. And, you get a country the size of Australia with the size of Australian financial resources to want to break in AWS. They can do it. You get a country of Canada that wants to break into AWS. They can do it. You get a state actor that wants to do it, they can do it because they've got enough compute power to do it. So we always have to think about the things that could happen. But generally speaking, if I have 2 things that are guaranteed theoretically to be 99.9% available, if I use 2 of them, that should get me to 99.99% available. So there is that. So you can, to a degree, architect around what they have, but I caution you, Aladino, to just assume or take it for granted that those SLAs really are going to get you what you need. I need you to architect around the SLA. So when that system goes down and people need to pick up their phone and dial 999, and if you're curious, look at that cute cat, that's my Cindy. But if you want to pick up your phone and dial 9999 to get an ambulance to come because you need it and it's not there, that reimbursement that ambulance squad will actually get for a couple bucks is not the ability to get there. So count it, and that's really going to go back to the budgeting, the side of things. But I want you to realistically look at it for real and look at what you can design for 5 nines versus 4 nines. And there's a big difference what you can design versus what they can design. And think about that, because you have control. You can say, I choose to be in these 3 clouds. They can choose to say, you're in my systems, but if their system goes down, you're done. From my perspective, what separates a good hybrid multi-cloud architecture from a truly great one? So from my perspective, here's how you define an architecture, a truly good architecture. So it fits the business's needs and goals. So if it's a hospital and they want a system that's going to reduce patient deaths, if the technology reduces patient deaths, it's a good architecture. If I have a retailer that's trying to increase sales with AI, and we create an architecture with AI and it increases sales, it's a good architecture. If I create an architecture that's supposed to increase sales and it doesn't, it's an architecture failure. So it has to fit the business, the needs of the business, the availability of the business, the performance needs of business, the needs of the way the customers access it. all comes down to supporting a business function. 80% of architectures are disasters. And why do I qualify them as disaster? Because they do nothing. They cost a lot of money and provide no benefits. So I want you to pretend you're the CEO of this business for a minute. You have $1 billion to invest. You invested in one thing and the business does $3 billion, and now you have the ability, the stock price goes up, you can give bonuses and raises to your employees. Now, you take the wrong decision, you spent it on the cloud and got nothing out of it, and instead of getting something that increased revenue, you got fired as a CEO because you lost a amount of money and did nothing for it. Or you didn't get fired, but instead of being able to give the employees raises, you have to lay off people because you didn't have an investment that was solid. That's what an architect does, and that's why the architect is focused on the business needs. That separates it. You can, if it works, fine, it works. But if it doesn't do anything for the business, it's just a waste of time and money. Is there something as an enterprise cloud architect or enterprise security architect? Are they different? They're different. When you hear the term enterprise security architect, all it is a security architect that works in a big business, an enterprise business. It is not an enterprise architect. An enterprise architect is focused on the organization's people, making sure they have the right people, the people have the right capabilities. Maybe they need to hire people, what have you, retrain the people. It is the processes. What are the ways the organization does its business? Do we find the most efficient way to do it? Can we automate it? What have you? How that business does its thing. And the technology that supports the business need. And maybe AI agents and what they can do to support the need. So enterprise architecture is about designing the business architecture, the application architecture, the technology architecture, the data architecture, mostly at a high level. And then we're going to bring in a cloud architect that's going to work as solutions architects to dive deeper on the technology. And we're going to bring in security architects that are going to dive deeper on the security. But enterprise architecture is a pure executive job. So walk in, meet with the C-suite, manage stakeholders all day long, convince the board to invest in something, find strategic roadmaps for a company. So that's enterprise architecture. Great job. Trained lots of people, and I've done it for 25 years. I love it. Why are many cloud architects now coming from DevOps or software engineering backgrounds and moving to chief architect roles focused on modernization? Panchi, I've never seen anybody that actually did that. Most of the work revolves around coding, refactoring, not solving business problems. Is this a misclassification driven by the CEO, CTO needs? So I've never seen that in my entire life, ever. In fact, I've interviewed thousands of people and I've never found the tech person. Now, I will tell you what does go on. I will see a startup where you've got 3 people and they were software developers, and one says I'm the VP of sales, and one says I'm the CTO, and one says I'm the CEO. I've seen a lot of that, but quite frankly, I've never seen DevOps engineers in chief architect roles. I've never seen software developers in chief architect roles, ever. And we're going back 25 years. Unless it's a small startup, or it was someone that was a great developer 20 years ago. And then for the last 25 years, has been management and leadership systems. But I've not seen DevOps engineers there. And the reality is, let's talk about the other thing, what I have seen happen. I have seen people be hired for architect roles. And I've actually done this myself. I've hired an architect, and I made a mistake in hiring them. I sent them on a meeting and the customer didn't like them. I had them on do a presentation and the customer didn't like them. And I hate firing people. So I've been, and many managers that I know also do this. What we do is when we've got an architect that doesn't know how to do an architecture, but they know how to do architecture. What we do is we keep them doing all those engineering things because they can't do anything else. So here, you're an architect. I hired you, but I realize you can't do architecture. So here's what your job is. Here, you go do this engineering stuff, and I'm going to keep you around. Now, the next time there's a layoff, that's the person that gets laid off. The person that I hired to be an architect that has no idea how to be an architect that's doing engineering. And I have done that, Punchy. I've kept people around for years if I could, because I hate laying people off. But that's typically what happens. You've got someone can't do the job, they get pushed in some silly thing until they get laid off. What's the best cloud tech to start learning multi-cloud? Learn the underlying technology, and here's the reason why. If you get an AWS solutions architect professional, and this is kind of scary, they don't tell you what an EC2 instance is. They don't tell you it's a virtual machine. They don't teach you how to size it with the right CPU cores or the right DRAMs. They made up a word to make a 1999 virtual machine sound exciting. Ooh, elastic compute cloud. It sounds so exciting, but it's a 1999 technology. And quite frankly, what we're saying in 1999, IBM in 1970 was time-sharing mainframes, which was the first cloud computing, if you really think about it. So the key is learn the tech. Learn what a virtual machine is. Learn how a container works. Learn how a container is orchestrated. Learn what a block storage is. Learn what object storage is. Learn what file storage is. Learn what a firewall is, how a firewall works, and learn all the underlying technology. And the reason I say this is this. If I teach you how to get into an automobile or motor car, depending upon what country, and I teach you how to accelerate, and I teach you how to stop, and I teach you how to turn, you can get into any Mercedes, to any BMW, to any Tata car, to any Hyundai car, to any Opel car, any car in the entire world, you'll be able to drive it if I teach you to drive. Now, what do you learn when you drive? You learn the components that work in every single car. The biggest problem in REM that I've seen is someone takes an AWS boot camp, and I actually interviewed 1,000 AWS certified people. And I asked them things like, what is cloud computing? I actually never got a single answer from any of the 1,000 certified people. I said, could you explain the difference between the three storage types we have: block storage, object storage, file storage? And even with AWS Solutions Architect Professional, they didn't even know what it was. And I say, how would you design a demilitarized zone? And they didn't know what it was. And I said, how would you design your wide area networking connectivity between the data center and the cloud? And they didn't know what a wide area network even was. So the key is you have to learn the underlying cloud. Join us on the architecture webinar. We'll talk about that, and I'd be more than happy to give you more information. Someone from my team can drop a link to an architecture webinar. Is upskilling and multi-cloud necessary to stay competitive? I'm going to start right there. 98% of enterprises are multi-cloud, so I can't hire anybody that doesn't know multi-cloud. There's only 2% of enterprises that could hire you if you don't know multi-cloud. So if you don't know multi-cloud, I won't consider you for anything because I can't manage to do that. So does multi-cloud strategy adopt increased cost? Well, cost, I don't know. Put 5,000 virtual machines in AWS and 5,000 virtual machines in Azure. That doesn't cost you any more than putting 10,000 virtual machines in Azure or 10,000 virtual machines in AWS. It does increase your availability. It does give you lots of other things. Now, you need to hire smarter people. But quite frankly, I can't hire anybody that doesn't know multi-cloud. So what do I care? Because 98% of businesses are multi-cloud. So is it unnecessary cost? I don't know. And what I mean by I don't know is I've designed systems where people lose $1 million a minute if they're down. And guess what? Investing another $10 million to save $1 billion that year is well worth it. Well worth it. But I've got other businesses where it's not worth spending an extra penny. I've got a hospital and somebody dies if the system goes down. I better put that multi-cloud, or if I don't, I'm partially responsible for somebody's death. The architect of the system that caused people to die, and I don't want that. So we always have to think about what matters, what are the business needs, what are the business contexts. But I can tell you right now, not only will I not hire anybody that doesn't know multi-cloud, I don't know anybody that will hire anybody at this point that doesn't know multi-cloud. Because just because it's not necessary to design a multi-cloud solution doesn't mean you don't need to know it and don't need to know when you should use it and where you should use it. So quite frankly, anybody that comes to me that only knows a single vendor, and I don't care if it's networking, if all you know is Cisco, but you don't know routing, I can't hire you. So and honestly, if you don't know the network and you don't know the data center, I still can't hire someone, because if you don't know where the cloud's going to break. So that's my perspective, and I've never hired anybody that knew a single vendor but didn't actually know the technology. Mohammed. Good to see you, Mohammed, and you're one of the hardest working people out there, so I've always had so much respect for you. Data center locations like Equinix or Megaport can be assets for resiliency, scalability, disaster replanning, and recovery. So what you have to deal with is when you get into a data center like Megaport, what they're actually doing is they become your new wide area network provider. So you connect to them and they connect to everybody else. So basically they become your new single point of failure. So yes, it's much cheaper to connect to someone like a Megaport for a small business. It is great, and I have no problem with it. Or if you need partial link speed. But remember this. If you connect to Megaport and Megaport has an outage, you've got nothing. If you use AT&T, which is one separate network, and Verizon, which is one separate network, and one of those goes down, you're covered. So, and I'm not sure, I'm not sure, I think you're in Somalia. I'm not sure what your actual internet service provider is. That's one of the few countries I've not been to for work. But, you know, kind of think about that. But here's the thing. If you connect to an Equinix or a Megaport and you know nothing about networking, the chances are that their available redundant network is actually better than you would actually do for yourself. So actually, that's something we should talk about. If you have expertise, then you typically don't outsource. And if you don't, so my background is designing mission critical high availability networks. My background is designing the networks that have some of the highest performance systems in the world for the largest enterprises, the world's largest internet service providers. When people kept coming to me and saying, Mike, I could save you money with cloud computing, I laughed. And I said, I spent less in 1 month and I'll spend less by buying it one time than you would charge me each month. And I proved it to them each time. So the key is it depends on how good you are, what your knowledge is, what your people's capabilities are. And also, Mohammed, what are your reliability things? What if where you're at, Megaport is the most reliable ISP or network provider? Well, that's okay too. So if you use Megaport, maybe use a second transit provider as well. Good questions. Alex, from a network security perspective, what are the biggest challenges architects must be aware of on a hybrid multi-cloud? So what are your real weaknesses in cloud security? Let's talk about that. So I'm actually going to give this one a couple minutes, then we'll talk a little more, then I'll get back to the rest of the questions. But this one I want to give a few minutes to. So if we look at the cloud, what do you have no control over, Alex? So if the cloud gets hacked, you have no control over it, and you're not somebody that's going to be able to fix the cloud's hacking when they're actually being attacked. You have no control over that. In the cloud, you have no control over the networking for the most part, the underlying infrastructure. You can't prioritize your traffic over someone else. So you've lost control of the network. In a data center, if you set the wrong permissions to a file sitting on a server, guess what? Then if I'm not allowed access to it, I might be allowed access to it if I'm on the same network, but if I'm outside the network, it's not reachable. You set the wrong permissions on something in object storage in the cloud, and now it's attached to the internet and people can actually access it. If you're in the cloud provider, Alex, and all of a sudden a company commits a crime and the FBI comes in and starts stealing, or they come in and they confiscate the storage arrays that the cloud provider has, your data, potentially your new proprietary secret formulas, are gone. And then the biggest issue with any cloud computing is the perimeter. And let me draw that, and then I'll tell you what we actually get to. And if you want, maybe I'll do another webinar on zero trust, because that's really what it's going to take. But I want you to understand these differences, because this is significant. In my data center, here's what we have. We've got our own private network that is 100% under our control. So we can do a lot more security things. So extra net security. Now, all this stuff in here, none of it can be reached from the outside world. Now, I've got the internet out here, and I want to have a web server. So here's what I do. I put my firewall here. And outside of my firewall, I say, let's say, well, here's our web page. All this web page needs to allow in is TCP port 443 for HTTPS. So we've got the internet, we've got our firewall, and we've got outside of our firewall in a secure DMZ is our web server. So We can go out to the internet. Our traffic is allowed to return back from the firewall. The firewall keeps track of our traffic, but nothing from outside can come in, only our return traffic. Now, internet traffic goes to here. Here's the web server, and it never enters our system. So this is what we have in the data center. All this really secure stuff in here, and we're using IAM and VLANs and access controls to microsegment this. And all the external stuff is outside of our environment. This is why you didn't see so many hacking events a few years ago, because this was fairly secure. Now we go to the cloud provider. Now we have to understand that the cloud providers are all, for the most part, connected to the internet at all times. Now here you're in the cloud provider, and here's your VPC, and this is where people go crazy and make really scary mistakes. So here's your internet connection, internet router, internet gateway, what have you. And now right in here, let's say it's a web app. So here's your load balancer. Now, right behind your load balancer, maybe you've got some containers, you've got some virtual machines. Now, I don't know if you've seen it yet, but I want to make sure you've seen it. Now, maybe behind this load balancer, you've got another subnet with another ACL, and here's a load balancer, and these are your app servers. Now, what did you notice here? So before, we weren't coming into our network, but now we're actually allowing stuff to come into our VPC, which is now connected with all this other stuff. So now being on the cloud, we've got a whole heck of a lot of nightmare stuff here. This is terrifying. So when we deal with cloud computing, if you want to know why we've had so many cloud outage and breaches, it's this kind of stuff. This is a terrifying environment. Now, if you segmented the network on the cloud, for example, let's say this was your web VPC, and then you had another VPC that you had private stuff. Now, all of a sudden, this gets mediated. Your private stuff goes in here, and your public stuff goes here. But most people don't know enough about how to design a demilitarized zone on the cloud or work around the cloud security weaknesses. So if there's that, so what does this ultimately bring us to? It brings us to an environment where we need to do a lot more. So what does that mean? It means if we've got a cloud, it means in any environment, we need some kind of IAM over here, ideally context aware for our employees. And typically speaking, we're going to do a couple things. We're going to, every time you want to request something, anytime, because we're going to verify everything. You want to request something, it's going to hit the context of where I am. It's going to assess the situation and the scariness of the situation and make a risk-based decision to allow you on or allow you not. When we have two routers that need to talk to each other from cloud provider A to cloud provider B, they are going to authenticate against each other. They're going to be using a public key encryption for this, typically speaking, to make sure that this router and this router are who they claim to be, that the messages haven't been changed along the way, and that nobody else can see it. So we're going to use encryption everywhere. We're going to segment by IAM. We're going to, in every possible environment we have, encrypt absolutely everything. We're then going to, let's say we've got inside of our VPCs and our VNets, we're going to basically create any kind of ACLs and firewalls anywhere we can. For example, inside of inside of here, let's say this is one subnet. No, we're going to protect this subnet and only allow what needs to come into the subnet. And then in any virtual machine, for example, or a container inside of this subnet, we're going to also put some kind of host-based firewall, endpoint detection and response. So even the device itself, the compute, has some kind of storage protection. These systems and operating systems have been hardened. Bad packages have been removed. Anti-malware stuff is sitting in these things. And of course, we're going to have, say, other subnets. And let's say you've got another subnet with a container. Now we're going to create ACLs in between these to make sure these subnets can't even speak to each other if they don't need. And we're not going to allow routing in between these kind of things. So we're going to determine who can speak to who. We're going to segment so that other people can't speak to each other if they want. We're going to be authenticating every request. We're going to be encrypting things. And then there's a lot more that's going to go into it. And I don't have a lot of time here to do it, but I am doing a completely free cybersecurity fundamentals bootcamp, and we can definitely get to that. So I understand there's a whole bunch of questions to do. So let me do this. Let me talk about content for about 10 more minutes, and then I will finish up on the questions. Let me see if... So now let's talk about... So let's now talk about kind of things to think about in our architecture along the way, and what we can do and what we can't do. And then some of this will actually come into security anyway. So let's play with this. So let's say we are going to have a demilitarized zone where our websites will be, web services will be coming from in each cloud. So how could we design this? So let's show for the security of the, let's say we've got an incoming web-facing application and the traffic is coming this way. You know, at the edge of our network, how are we going to secure that web traffic? We're going to use a CDN. And guess what? A single content delivery network is a single point of failure. So if it matters, we're going to use both. And if any of you want to check, you can open up a terminal window on your Mac or your Linux machine. You can open up a Windows PowerShell window and type the command ns lookup. So November, Sierra, Lima, Oscar, Kilo, Uniform, Papa, and then type www.amazon.com. And I bet you find they're using multiple content delivery networks. So by using two clouds, we almost always use two content delivery networks because this becomes a single point of failure. Now, typically speaking, behind our content delivery network, how are we going to secure this web application? Well, typically speaking, we're going to put a load balancer. And behind the load balancer, we're typically going to use two sets. We're going to use the next generation firewalls. And these are going to be AI-enabled firewalls. And so we'll call this a next generation firewall. Now, if it really matters for our web application, let's say these two are Cisco firewalls. Cisco makes a great firewall. Then again, so does Palo Alto, so does Fortinet. But the way Cisco does things might be a little different than the way Palo Alto does things. So it's kind of like martial arts. We might need more than one firewall. So most of my life, I studied one martial art, and then I studied jujitsu because I wanted to learn what happens if I got stuck on the ground. So same kind of situations, we use multiple firewalls if it really matters. So let's say it's a web application, and we're using firewalls. Now, I'm going to make this very clear. This firewall cannot be the cloud provider's native firewall. It's got to be a Cisco, Fortinet, Palo Alto, something like that. And it's going to be a better firewall anyway. Then we're typically going to put another load balancer. But instead of next generation firewalls, we might be using IDS, IPS systems. Now, there's a reason we're going to be using them. Sure, the next generation firewalls have them, but why not? Just in case. We might get better. But also, more importantly, and I'll show you what's going to happen next. And I'm going to show you what we won't be using and why it doesn't matter so much to us. So here we've got behind this. Now let's say this is going to be the load balancer that's front-ending our server. And this is going to be the external IP address of the load balancer. If we have the opportunity, we're going to put a web application firewall on this load balancer itself, some flavor. And this is by putting a web application firewall, if it's possible, depending upon if it's possible based on your architecture, that's going to protect against web-based exploits, specifically speaking. Like if not, you can put it on the servers, and those firewall will protect against web-based exploit like SQL injection attacks, what have you, in case your applications are designed wrong. And then you're going to have the endpoints themselves. Now these are going to be, let's say, your VMs. But it's an endpoint. I don't care. It could be a container. We have to protect these containers or these VMs because coming out of the board, the operating system's not secure. So we're going to have to really lock it down, get rid of unnecessary packages, close down any open ports, and we're going to put some kind of endpoint detection and response. EDR, XDR, whatever. But we're going to put some kind of endpoint detection and response on this. Why? Because what if something gets past, a DDoS attack gets past the content delivery network and the first set of firewalls and the second set of firewalls and the IDS IPS system and this WAF? Well, the machines themselves are locked down. Now, these tools that we're going to be used are going to be industrial tools that go on any cloud provider. And what are we going to do next? We're going to have to centralize our IAM. So we're going to be using some kind of centralized IAM, which will be federated back to the cloud provider. This is great. Now we get into the big boy and big girl tools of IAM as opposed to using the cloud provider's Swiss Army knife approach of almost good enough, but not great at anything. Although Azure's got some pretty good IAM tools from their experience in Active Directory all these years, but as a rule. So we've got centralized IAM. Now, are we going to be getting any kind of information like security logs from these firewalls and IDS, IPS systems? Well, we're going to an endpoint system. We're going to get a lot of it. So that means in our multi-cloud architecture, what are we going to use? We're not going to be using stuff like Macy to figure out what's going on in AWS, but we are going to be using some SIEM and source systems, and I'll show you what they are in a minute. And what they are going to do is they are going to aggregate the logs that are coming from all your cloud providers and all your stuff. So you can see if an event occurred, where it occurred, correlate the event, and in many cases, the AI and the source systems will solve an event real time. So now let's play with it a little bit and see what these applications could look like if we ran them in both clouds. That would be the demilitarized zone that you would use to say, keep an application secure. So let's pretend we've got a couple of virtual machines and a couple of clouds. Let's talk about what will work as opposed to what won't. So if this is cloud provider A, and this is cloud provider B, and we have 50% of our website in both places, we clearly clearly have a problem. Are we going to stick half of our stuff on AWS, say Aurora, and then whatever the Azure or Microsoft SQL Server is, or whatever the Azure primary server is? I don't want to say SQL Server because that would be different. And now if we use one database here and a different database here, what do we need from an architecture perspective? We need to create middleware that's going to be translating between the stuff. Yeesh. So whenever we translate between stuff, stuff gets ugly. Why does it get ugly? How many of you speak more than one language? If so, tell me the language you speak in the chat box. But some things don't translate. If I say to another Greek person, I'm going to change your like, those are fighting words. That's a bad thing to say. But, you know, if I were to say to my American buddy, I'm going to change your lights, they're going to say, oh, are you going to replace them with energy efficient light bulbs? So some things don't translate. And the key to remember with middleware going here is some things don't translate. So it's never going to be perfect. And we're going to add a lot of complexity here. So don't do it. So instead of using some DynamoDB that AWS made, in addition to their other 18 million things that they're trying to make, what if I use Apache Cassandra? I can use Apache Cassandra in both clouds, and these two can synchronize with each other. They're constantly going to stay sunk up. So I don't use the thing. Sure, I don't use the AWS Elastic Kubernetes service. I don't. I use OpenShift that works on all clouds. So that's really the secret to making this work, is just don't use the cloud provider's tools. So when you go through an AWS certification, they don't tell you what the stuff is, and they made up all their AWS security tools. You're not using it. That's why anybody that's done AWS training, I have to retrain them, because you can't use that in most environments because it's not robust enough. And not only is it not robust enough, it doesn't work multi-cloud, and 98% enterprises are multi-cloud. So those were kind of things we're talking about. We are talking about a 3-hour conversation versus 1,000 hours when we normally train an architect. And I've been told there's over 8 questions waiting in the background. So I'll stop here for questions. And if you've got questions and you want me to whiteboard something, I'll whiteboard it out along the way. So Chris from my team, bring me some of the questions that existed, and we'll take it from there. What emerging trends in hybrid or multi-cultures do you believe will have the biggest impact in the next 3 to 5 years? So, in production, it's really funny. So when I started this program 5 years ago, every person that came to me, I said, you must learn multi-cloud. I said, you must understand where cloud computing is ridiculously expensive, where cloud computing makes sense, where cloud computing's weaknesses are, where cloud computing's strengths are. I said, because if we just view the cloud as some exciting thing, what's going to happen is everybody's going to send their stuff there. And as they send their stuff there, they're going to realize how much more expensive it is, how much less secure it is, and how much more complicated it was when they thought it was going to get simpler and elegant. And what have I seen in reality? Well, 83% of organizations are in the middle of a cloud repatriation, which is exactly what I was told, what I said was going to happen 5 years ago. No. You may have seen me write in articles, Data Center Magazine articles. I've been in Tech Republic, Tech Radar, Forbes, everywhere. And I always talked about a few things. One of the things I always talked about was you can't have a single cloud. So I didn't think we were going to go from people that thought it was okay to use a single cloud to 98% enterprise adoption in less than 5 years. And I didn't expect the cloud repatriation movement of getting off the cloud to be as fast as it actually was. I knew it was going to happen, but I thought it would take an extra year or two before people realized, wait a second, I went to the cloud. My business didn't get any better. I'm spending a whole lot more money. It doesn't perform as well. And now we've had these breaches that we didn't have in the past. Let's get the heck out of this. This is a reversible mistake. So I think there was a lot of it. And yet at the same time, I found many companies underutilized cloud, in that they didn't understand what the cloud could have done for them. These batch workflows, these batch things that it could be used, train a model on the cloud because you've got a capacity on demand, bring your model back to your data center. And that's where we're going. And I see it. Now, if we look at where the majority of the money is being spent right now, it's not cloud, it's private data centers. And AI is driving that. And why is AI driving that? Well, cost and actual performance, and also control. Companies have had a lot more security breaches than they actually occurred in the past. And the reality is it's not the cloud providers. It's not. The cloud providers are running excellent businesses, but most people don't understand cloud computing. If they don't understand networking, they don't understand security, and they don't understand the way the hardware pieces talk to each other and the underlying software and the underlying control plane, if they don't understand that, then what you find yourself in a world is people designing things that they don't understand. Now, I have to tell you, I'm a medical person. I wouldn't do surgery, a kind of surgery that I don't know how to do. I wouldn't. Now, maybe if I was stuck in the middle of the woods and we were 80 hours away from everything and a patient had 30 minutes and they're going to die, would I attempt to do it? Because they're dead anyway, so I might as well try because it's the only hope we have left. But I know internal medicine. I'm not fully briefed at surgery, but I understand. So you get the point. But unfortunately, we're seeing a lot of that. We've seen so many people. They got a couple of certifications. They thought they knew something. That 5 years ago, when everything was COVID, they migrated to the cloud. They haven't been laid off yet, and they're making very bad decisions. So I've seen so much of that. What I'm also seeing is some of those people that went to the cloud that didn't understand it, specifically on the engineering side, is being laid off. And you can also see where I talked about it years ago, where I talked about, I also talked years about engineering positions being automated and architect jobs being hired more of. And you were saying that day after a layoff, more architect jobs, more architect jobs, more architect jobs. So I think what you're going to see is everybody is going to be some flavor of hybrid cloud or hybrid multi-cloud, because each cloud provider does have some offerings that are pretty darn cool. And it would be sad to not use the cool offerings. For example, if you were going to get dressed and you found that you like to wear Canali suits, but you like to wear Thomas Pink shirts, and you like to wear suits that are made by Echo because they're comfortable on your feet, it's just by nature we wear and live in a multi-vendor environment. We don't force ourselves to get everything from the same vendor for everything we do. We don't. For example, I love speakers. I love speakers. I love sound. My speakers are made by Kef. My amp might be made by Marantz in my house, and my TV is made by Samsung. And all of that could still go into a perfectly great home theater system. But the point is that's where I see it. I see many more architectures going back to the best old days, where we really take that best of breed approach, where we're designing something that matters and we say, oh, this is the best engine, let's use this. These are the best seats, let's use this. This is the best stereo system, let's use this. There's no reason to ever leave all your eggs in one basket. There's no reason in general rule to ever say, why would I deny myself the best tools? Kind of like a doctor. What if I could only prescribe one kind of medications from one company? That would be ridiculous. And that's what we saw with cloud computing. The physicians prescribe every medication and surgical treatment that's available to save their patients. And that's the trend I see. Getting rid of the ridiculousness, the silliness of don't worry, we can do it all for you. Businesses learn they can't, and they're going back to some flavor of a hybrid. And honestly, I think the hybrid cloud makes most sense for most people, because the data center is the cheapest and most secure if you know what you're doing. And but you use the cloud for the scalability and the agility. So want to try something new? Explore it on the cloud. Do it faster than your competition. It works great. Now bring it back to your data center 2 years later where it's going to cost half. But get the speed, get the agility. Great question. Just like Route 53, why can't F5 DNS go down? Isn't it a single point of failure? No. And I'll show you where the single point of failure would be. It's a great question. So Raja, if we put all of our F5 DNS, and what I want you to understand via F5, this is just a server. So it could be standard DNS bind. It doesn't have to be a DNS. But this is an independent system over here. And this is an independent system. So this stuff is really talking to something up here. So it's talking at the DNS hierarchy. So you can lose this entire cloud. It can all go away. And this is going to take over, because this is not some vendor in the sky, Raja. This is an actual server or servers that you're sticking in each one of these places. So this server goes down, another server in the same provider will take it down. A whole provider goes down, this completely separate cloud. And for the most part, these two don't have a lot to do with each other. It's this going in this direction. So that's your real issue. You don't need two different vendor products here. Now, the only time you would ever get into a real issue, Raj, is if you had a serious bug in the F5 environment, which is another story. So would you typically run two infrastructure providers? Not necessarily. This is typically what most organizations are doing, because they're going to have a cluster of servers. And typically speaking, that's why it's not. But if we put all our F5 servers in the same cloud and the cloud went down, just like Route 53, we'd be in the same place. But this is run by completely different people. This is heavily separated from this. So you, generally speaking, should be good. The only thing that could take all these down is if we had some major internet issue where someone took down major parts of the internet and the wide area connections that are connecting the cloud providers. But that's an even bigger kind of failure at that point. That's probably a war or something serious, where people are attacking the undersea cables. Good question, Raja. What's the difference between an enterprise architect and a chief architect? So they're both enterprise architects. So let's kind of work. You know what? Let's have some fun with this. It's a good question. So let's kind of look at an IT organization. So we're going to stop with the top of the organization, which is going to be the C-suite. It's going to be the CEO who sets the strategy, the COO that figures out how their business is going to be run, the chief financial officer, what have you. And then you're going to have the chief information officer. So I'm just going to remove all the other executives right now and just keep the chief information officer. So this role right here, Jose, is the top strategist and the top operations person. So we typically have, under these environments, the CIO is going to have a chief architect in an enterprise. Now, this is a heavy-duty executive role. Now, in many cases, this is a $500,000, $1 million enterprise architect role. What's different? This is the extreme executive, pure strategist, much more polished, very, very smooth. Now, you typically have someone that's going to run the IT department, which is typically, depending upon the size of the company, say a senior vice president of IT or an executive vice president, depending upon the company, size of the company. You typically go and they run the operations, and you're typically going to, in most companies, going to have a chief information security officer. And in a serious security company, you'll see the chief information security officer here, but in most companies, it stays here where the CIO is still the first class citizen. And sadly, the chief information officer is the second class of citizen of the executives. Not my rules, but whatever. If we typically down here, these are the people, the engineers that are going to be doing the job. Under here is the security operations side. So if we go down one level, this is your enterprise architect. And I'll tell you what we're doing here, and I'll show you the difference. Now, in a big global enterprise, there may be 20 enterprise architects that are sitting there. The chief, and we're all going to be feeding into the CIO, to the chief architect, to the CISO, and we're even going to be talking to the rest of the C-suite and the board. So here, this is really... this is a senior executive role. So there's not going to be a lot of tech there. When we get to this enterprise architect role, it's typically about 85% business or more, and maybe 10 to 15% tech at most. So when I work in these roles, I definitely put on my Armani and Canali suits. When I work in these roles, I often do, but not 100% of the time. Now, this person is responsible primarily for business things, people, processes, and technology, but this person might have 15% of their job focused on tech, and this person has none of their job focused on tech, and that's the reason this person earns more. It's the sickest thing ever, but the more your business skills are, and the less people see you as a techie, the more you earn. I didn't make up these rules, but I've helped people add a few $100,000 to their career, and usually it's a combination of hiding the tech skills while showing the tech strategy and developing business acumen. But there's that. So kind of keep that for, in the back of your mind. So if we go down one level, and I'll kind of show you where they're all playing, because I answered your question here. Here's, realistically speaking, in today's world, your multi-cloud architect is your next level down. And the reason I call it a multi-cloud architect, it's the architect that's dealing with the data center and the cloud, or your 2 clouds or 3 clouds. Now, this is 95% of enterprises. Now, David Lithicum's a multi-cloud architect. I'm a multi-cloud architect. Anybody that you'll see that's made it to principal, distinguished, or any real level is a multi-cloud architect. So when we're here, we're still executives. It's 75% business, but about 25% tech. So we're still talking tech strategy here. But remember, the cloud is everything. It's our servers, it's our storage, it's our network, it's our compute, it's our security, it's our AI. And whether it's a data center running Nutanix or a data center running VMware, still the cloud. So that's kind of your next person down. Now, the reason is, I promise you can't remember all the stuff on all 3 cloud providers, plus all the other non-cloud providers, plus the name of Nutanix's stuff, the name of Cisco's stuff, the name of Palo Alto's stuff, the name of FortiGate stuff, the name of Okta's stuff, and every other provider you're going to use. So this is a generalist role, kind of like the family practitioner. So when you deal with a generalist, if you go to your doctor because you've got a sore throat, the doctor sees your sore throat, they notice you have serious hypertension, and they say, Mike, I want you to go see a cardiologist. So they send you to an expert. And when I worked initially in my life as a primary care provider, patients came to me, wait, you've got a broken arm, I know how to cast it, but I'm going to send you to that orthopedic surgeon just for a consult. Wait, I notice your blood sugar is too high, you're going to see the endocrinologist. Wait, you have some kidney things, I'm sending you to the nephrologist. That's the role of the multi-cloud architect, is to farm it out, build an architecture team. So it's predominantly a leadership role. And now, who are the other specialists that we're going to need? Well, if we're this multi-cloud architect, we're going to get account teams, which are going to be solutions architects, and sales reps that are going to try to convince us to use their stuff. So they're going to be the solutions architects that are going to be trying to design a solution and try to sell it to us. AWS is going to send their people. Azure are going to send their people, because solutions architects are not meant to be trusted advisors. They're pre-sales, like a sales engineer, but ideally in a perfect world with a little more business acumen. Not always depending upon the cloud provider. In a real solutions architect role, yes, but not in every company. Now, I'm also going to have expert architects that are going to work for me, like an AI architect. And the AI architect is going to be 60% business, but 40% tech, and their world's going to focus around AI. So I'll have some AI people working for me. Good question, by the way. I'll have some networking people working for me, network architects. I'll have some security people focused for me, like a security architect that's going to be an expert there. I'll have an IAM architect potentially if it's a really large organization. And the IAM architect will be focused on the IAM strategy. I will have application architects, and these are all the specialists that will give us guidance as either multi-cloud architect. They feed it into the cloud architect, who then feeds this into the enterprise architect, who's partially working on strategy for the organization and processes and other things. And they will all be part of our architecture team. But of course, we're also going to get more solution architects because we've got AI, right? So who's going to want to sell us AI stuff? Well, everybody, really. So we're going to have NVIDIA solutions architects. They're going to be trying to convince us to use their tools, and they've got some great tools. AMD is probably going to come in and try to convince us to use their stuff. Maybe somebody that makes a model wants us to use their stuff. So we're going to get solutions architects from these folks. So down here, you're focused on designing whatever your specialty is. Still mostly stakeholder management, business compositions, and executive skills. Over here, you're the generalist that's building the team that's going to guide you through this. Over here, you're focused on people, processes, technology, even AI agents and strategy. And when you finally make it to here, you're just about the C-suite. So you're much more like a CIO or a CTO or a CISO, super, super executive, but now you're focusing more on strategy. So lots and lots and lots and lots of business acumen there. Good question. Chris, we go to the next one. Is it feasible to land a principal solutions architect work without a formal solutions architect role? If so, what would it make it to get to that tier? So I became a principal solutions architect in 2 years, Alex, but it did take me 2 years. So what was the difference between my solutions architect role and principal solutions architect role? And I think my team can drive a link to a video I made about that. In my first solutions architect role, I was designing a strategy. One, I'd see a client, I'd design a strategy. I'd see the next client, design a strategy. Then when I made it to the principal architect role, I became more of an architect to the solutions architect. So what do you mean? So I was an expert on two things, BGP and IP multicast. Those were the two things that I had deep knowledge, real deep. So anytime there was an IP video issue, they'd bring me in. Anytime there was an M-bone issue across the multicast backbone, they'd bring me in. Anytime there was an opportunity to write a paper to shift the industry, they'd bring me in. Mike, we're trying to deal with this big internet service provider. They want TV services. I need you to spend the next 6 months with them. So that's the principal architect role. The solutions architects call you, Mike, I'm on a big thing. I need guidance on this. Mike, I need guidance on this. Mike, I need guidance on that. So that's the principal solutions architect role, where the first one is just one customer at a time. What does it generally take to move into a principal architect role and a distinguished architect role? And I'll have my team drop a link to that video. Typically speaking, some domain expertise. Typically speaking, extremely pristine communication skills. So when they bring you in for that multi-billion-dollar customer, and that's where they're going to be bringing you, it's your knowledge level and ability to explain it to make that customer say, ah, I see it. I get what's in it for me to use that actual technology. So that's what I'm talking about in the principle, that person that can walk in, more executive presence, more gravitas, command the room, and then deliver a level of incredibleness. So, that's what you're typically dealing with in the solution, in a principal solutions architect or a distinguished architect. potentially working in working groups, potentially working with like the Internet Engineering Task Force or the IEEE to come up with new standards. Being able to create strategic roadmaps for your company based upon what big companies are recommending, being able to make recommendations on product and services for the future. That's the job. So generally speaking, I've not seen anybody get a principal architect job as their first job. But Alex, at the same time, my student Nafuli got his first job as a chief technology officer. And I've had many people like Wallace, Wallace Agana, for example, in Manchester, whose first job was an enterprise architect, which in many cases is a bigger role than the principal solutions architect. But that principal level usually takes some expertise and usually a couple years. Great question. Beyond designing systems and working with teams, is any architect's biggest impact presenting solutions, trade-offs, value to the C-suite? So here's your real value, Andrew. What impact can you make? So if someone comes to me and they said we had 10 deaths related to medical errors last year, we want a technology that can reduce that to 3. And I can figure out where an inefficiency is in the way they do things at the hospital, and that can stop 2 patient deaths with no tech at all, just changing the way we do things. And I also determined that a weakness in the system is some application that's causing the nurses and doctors to do something differently. And then I swapped that out, and the patient went from 10 deaths to 2. Now I'm a really good architect. Now, I worked with a hospital one time, and I'm literally not joking. We were finding where the nurses, they were doing like an hour and a half of overtime each day, put some pedometers on the nurses and found they were walking miles extra to an ice machine. We dropped the second ice machine in because we saw that was the inefficiency, and we dropped about an hour of overtime per nurse per day. $75 an hour of overtime. That was a lot of money because they had like 800 nurses in that hospital. So we have to look at the biggest architectural impact. Sometimes the biggest architectural impact is not technology. It's making a modification to the business architecture. For example, Andrew, I've got 2 sales reps. Sales rep 1 is really smart, really good, communicates well, has everything attribute you can want, but can only sell $2 million a year. Sales rep 2 can do $13 million a year. Well, the biggest impact that I can do in that situation is to figure out how that one person always sells 6 or 7 times more than everybody else, and figure out a strategy to make that happen, figure out the processes to make that happen. And that's enterprise architecture. I may not even need to touch the technology. Now, I might find that sales rep has a little cool tool that sales rep built for themselves, and they're making themselves better. So then maybe I say, ooh, let's look at that tool. How do we use that tool? Do we tune the tool? Do we keep the tool? We make it better, and then we roll it out to all the sales reps. That could be enterprise architecture, where we figure out what we're trying to do. So the biggest impact is the change you make to that organization. So let's talk about the presenting, the selling solutions, the trade-offs. We have to be able to do that. And here's the reason why. There is nothing good. There is nothing bad. There is only what's appropriate. I think I actually have on my desk from an example I was doing with my students 2 weeks ago. I'm going to give you 2 medications, and I'm going to show you the good and the bad. This is a nasal decongestant. If you've got allergies or a nose, or you've got a cat that wants to sit on you every day, and you've got sinus congestion. By giving this medication to a patient, here's what I want you to notice. It's going to constrict their blood vessels, which is going to raise their blood pressure. It's going to speed their heart rate, and it's going to give them a little stress, activate their sympathetic nervous system, which might not be good for someone, depending upon their cardiovascular mortality. Here's another one, methylprednisolone. This is something that I prescribe to many patients. Here's what happens when I give it to them. It shuts off their immune system, which makes them likely to get sick. It raises their blood sugar into the diabetes range. And it knocks out a whole bunch of things. But if you're not breathing because you had an asthma attack and you can't breathe, and I give you an IV of this stuff, you're going to breathe very soon, and it's going to save your life. But if I give it to you too long for the wrong reasons, I give you osteoporosis, your muscle wastes away, you get diabetes and you get every virus and bacteria infection you can. So the key is to really be able to evaluate the problem, to really be able to see what the options are, recommend the right option after evaluating the trade-offs. There are many patients that I would give those two medications to, many. And there were other patients that I've got someone with high blood pressure that I say, I can't give that drug. So the key for you is just like being that physician or that nurse practitioner or that physician assistant, to be able to walk in, figure out what the right problem is, and then make a recommendation to make them better. That's the value to the C-suite. Now, the other thing to remember is you are a consultant. And why is that important? So we can never be truly objectives with ourselves. If I get sick, I don't write a prescription for myself. It's really not a good idea to do it because I can't diagnose myself accurately. Now, I call my wife in, who's an internist, and I say, Lisa, could you take care of me? I'm sick. Now, she's not me, and I do the same thing for her. So sometimes the biggest impact is to be able to look at things objectively, being able to find out where the weaknesses are, where the pain points are, where the challenges are, and make the right kind of recommendation. That's the value to the C-suite. The real value. Good questions. Given the power consumption is a significant bottleneck in data center operations, can underwater data centers effectively trade off increased maintenance complexity for substantial energy savings? I don't think so. I think the reality is we need a whole lot of power, and we're going to be putting nuclear power plants absolutely everywhere in order to power it. You know, we have to talk about reality versus people talk. For example, a lot of companies say we are going green, and because we're going green, we're going to reduce our carbon emissions. To do so, instead of holding 10,000 servers, we migrated the 10,000 servers to the AWS cloud. Now that sounds great. I'm not using any of the power, right? I'm now a greener company. But now AWS has to buy those identical 10,000 servers that use the same exact electric, but I just changed the electric and moved it somewhere else. Let's face it, we've already reached the point that the cloud providers are building nuclear power plants. Microsoft's already made its arrangements, and that's where we're at. The concept of being able to use electric cars, we don't have enough electric to power the country that we actually have right now, the world that we actually have now. So we're going to see a huge bump in power infrastructure for this AI. We're going to see a huge bump in all of it. And can you do it under the ground? I don't know. It's very hard to do it, lots of these things. Now, could you relocate it into cold places? Could you have an air-cooled data center in Canada? Yeah, you can. Could you have an air-cooled data center in very cold environments? You can cut that back, and you can get to them much easier. So where you put them, kind of be there. But, you know, you've got some companies that are using a river to come in to cool stuff down. So if we get smart, we can get creative on the power consumption side. On the side of it, you definitely could get creative, but we need far more power than you can possibly imagine. And we are nowhere near it. So I expect lots more nuclear power plants to be coming up. And I don't expect people to be too worried about power savings. They'll say they're worried about power savings. And then what I think is going to happen, they're going to be build systems that need terawatts of power. But I love the idea of using any natural resource whenever possible. But, you know, the other thing to remember is systems theory, Kingsley. And I know you really well, and I've always appreciated it. And here's systems theory. If I throw a rock into a pond, it's going to have ripples. If you drive your car with a flat tire, it starts with a flat tire. Then there's a problem with your suspension. Then your frame bends. Then your wheels bend, and all kinds of bad things happen. If we take a data center and then stick it in the ocean, that's going to raise that area's the ocean temperature. What's going to be the impact on the fish that are there? What's going to be the impact of that on what you're talking about, for example, on the ecosystem in the ocean? So whatever we do, there's nothing free. Nothing. So that's really going to be the secret there, is to be able to figure out what the actual impact is. And can we tolerate the impact or can we not tolerate it? So when in architecture and medicine, what executes a good trade-off? What we're getting is worse than we're actually losing. So I give this methylprednisolone to someone and it keeps them from dying. It's a really good trade-off. Mike, my knees bother me 2% today. It's not worth that trade-off. So even though it will help with knee pain dramatically because it'll shut down the immune system, it'll therefore shut down the anti-inflammatory process. So that's what I really want you to think of. What are we gaining? What are we losing? Oh, I use this native AWS tool. Wonderful. I gained simplicity and elegance, but I lost X, Y, Z. Now, if X, Y, Z doesn't matter to you, then you actually achieve something great because it's not a trade-off that you care about. Now, if it's a trade-off that you care about, then you can't make that. And that's really architecture, is trying to be able to figure that. But love the idea. Do love the impact of what it could do, but I don't think it's going to be that great of an idea, or Microsoft would still be doing it. I think ultimately it was a very cool scientific experiment. Great question. Mina, every company offers its own multi-cloud solution. How do we know which one will work for our loads and which one won't? How do you choose the right platform? So not really. So AWS does not really talk about multi-cloud solutions. Oracle talks about multi-cloud solutions. Google talks about multi-cloud solutions. Even Microsoft talks about multi-cloud solutions. AWS, for the most part, stops at one thing. I have a hard stop at at 5 o'clock, everyone, but I'm going to do the best I can to keep working. So we have to think about that. How do you choose the right one? Well, the real key to look at is, what are your organization's needs? What are their business needs? The needs determine what your solution is. How do I describe what medication I pick for a patient? I look at the patient, I look at the patient's condition, and I look at how that medication will impact their body. Will it impact the other medical conditions I have? For example, if I have a diabetic and I give corticosteroids, I'm going to raise their blood sugar. If it puts them into the range where it's dangerous, I can't give that corticosteroid. I have to give something else. So that's what I really want to look at. Same thing here. I want to look at what is the impact of the choice on one business. What is the impact of the next choice on the business? What is the impact on the third choice? And when I know what the actual impact is, then I can ultimately make my thing. So how do we typically do it in business? How does the C-suite decide? Typically speaking, one of the analysts or someone that's got some number crunching ability will be able to create an expected value of an opportunity. So opportunity one has a 50% chance of yielding $1 billion. That opportunity is worth $500 million to us. Opportunity two is 95% confidence interval that we can gain $600 million on that. Opportunity two is a better investment because our confidence interval and our expected value of the opportunity is greater. I know your name, so since I know your name, you're going to get to build some of these financial calculations with us. But that's realistically what we're talking to. We look at the architecture, and then we ultimately will build the matrix. So that's a great question, Mina. So I'm a chief architect. AWS has given me their proposal. Azure has given me this proposal. Cisco has given me additional proposal. Now, when I look at the Azure proposal, it's going to really help me in all those things that I need. And it's going to affect 2 or 3 things that I don't like, but that doesn't really concern me. Now, when I use the AWS one, it does a better job at 3 of the things that I need. But 2 of the things that are important to my business, it doesn't do poorly. Most likely I take the Azure one versus the AWS one. Unless those 3 things that it does better AWS are going to be more financially worth it than the pain points or the trade-offs that I face. That's what you do. So we're going to take it, we're going to look at it, and we're going to bring it all down to the ultimate things. What a great question. Great question. And then we typically will basically say features and functionality worth 20%. Reputation of the provider is worth 20% of the score. Impact on our future goals is a part of the store, that kind of thing. What would it take to build a meta control plane that uses AI inference to coordinate multiple now cloud native control planes, control tower, Azure Arc? Okay, so a lot of those things, Jose, are not control planes that you're describing there. They are actually controls that we actually put in place. So you're not really talking about control planes there. There's the concept of a super cloud where you basically have an abstraction layer there. And there are some providers like Cloudflare that enable you to do that. They enable you to put a firewall anywhere in the world on any cloud provider at any time. They enable you to provide transport for anywhere, anytime to kind of coordinate that. But then you have to worry about that becoming the new single point of failure. And that's what's ultimately going to happen. If you build one super control plane over two other control planes, your new super control plane becomes your single point of failure. What will differentiate future cloud leaders? Those that play AI or those that let AI design itself? Neither one of those are cloud leaders. Neither one of those are anybody I ever want to have on my team. And here's the reason why. The person that solves my business problem, I hire, and I don't care if they can design an AI solution that works if it doesn't make my business better. Who cares? Hey, I can make this thing. It's going to cost you $10 billion, but you're going to get nothing for it. Okay, I'm not giving you my money. So let's be fair. And if the AI designs it, who cares either? Because I'm not buying something that doesn't work for me. So what differentiates a real cloud leader? They can deliver real results. If a cloud leader goes to a hospital and less patients die and less medical errors are made and it costs less money to deliver and reimbursements go up, that cloud leader did a great job for that hospital. If they go in there and they take tech that works and they move it from there to a cloud and it still works, but the hospital is still struggling, they didn't help them at all. So the difference is the outcome that you make. Just like a surgeon. The surgeon that makes you better is the surgeon you go to. The surgeon that cut you open and has skills and has a degree from Harvard, but you can't walk after the surgery, that's a bad surgeon. Or a surgeon, you had surgery, they have a pedigree, they did the surgery and you're not 100% better, or you're not better at all, but you just got a new hole in you or a wound, that's a bad surgeon. So that's really what I want you to think about. How do you architect for decisions you can't predict but must be ready to explain? You can predict them. I can predict a cloud control plane failure. I can predict a cloud attack. I can predict what happens if a DDoS attack were to occur. I can predict what happens if a core router goes down. And we architects always do that. We constantly take a game theory and we look at it. It's often called raid teaming. And whether it's penetration testing with security people or the other architects coming at it, what happens if this attack? What happens if this attack? What happens if this attacks? What happens if this attack? That's part of every architecture we actually design. We can predict them. We must predict them, and we must know what they are. If somebody can't predict what the failures are, they need to be they still need training before they try to work, because they need to be able to see the failures. And actually, that's the big difference between people that have been building and people that have been designing. When we design, we focus on all the elements and we know where the failures are. Okay, if this link fails, what's going to be the backup link? If this power distribution unit fails, where's going to be the backup? If this control module on this router fails, what's going to be the backup? If laser fails on this, what's going to be the backup? If a backhoe comes and digs up the street, what's going to be the backup? If a submarine cable is cut due to war, how are we going to reach the other thing? So the key is we can predict them. And we have to be able to explain them. And we have to also, like from a security perspective, that's why we get various threat matrices, say MITRE and MITRE ATT&CK, where we can evaluate various threats and new threats, because we can predict them. We just need to know where to look. And that's the difference between architecture, is often knowing where to look, knowing where those matrices are, knowing where that information. So you actually had some really great questions. Really great live. Looking forward to the security live on Thursday. Andrews, thank you. I'm looking forward too. And Adrian, yes, the outcome is what matters. And Jose, you're more than welcome. So Jose, we're doing security fundamentals, not security architecture, but we do have security architecture training. A lot of interesting design, Mike. Thank you. Some you've seen before. Great to learn over and over. And that's the thing. You really have to be able to look at the architecture patterns and figure out where you're actually going. So thank you all for coming. It was so much fun to see you here. I really hope you got a feel for what we really wanted to talk about today, which is multi-cloud, which is how are clouds built, what goes into the cloud, and how they fail and where the failure points could be. We talked about the kinds of cloud failures and what would be catastrophic and what would be survivable. We talked about the trade-offs between cloud architectures, because not everything should be multi-cloud. Not everything should be hybrid cloud. Not everything should be in the data center. Not everything should be in the private cloud. So we have to realize there's strengths and weaknesses of every approach. We talked a little about that. And we kind of determine, your gold, your platinum, your kind of thing. So the mission critical application, yeah, make it cold, but multi-cloud. But maybe something that doesn't matter, don't do it. And then we had some fun. We got a little geeky. We did some whiteboarding on multi-cloud architectures. So if you had a good time, please give the video a like. It helps us dramatically and social media wise. If you thought it was valuable, maybe subscribe to our channel and hit the bell. And please join us on the next 2 free things we have, which is a security fundamentals boot camp coming on Thursday. Sign up and register. It's going to be 4 hours of security fundamentals, and it's going to be a lot of fun. And on Friday, we're going to have a webinar on how to become a security architect and talk about what we do as security architects, the skills that you need as security architects, how to get hired, how to stand up, and everything that is great. And maybe give me a hashtag multi-cloud one more time. It's good for us. It's good for the algorithm. And that way we know you are here. And thank you all so much. Wonderful, wonderful.